Welcome. It is a great honor to stand here today as we celebrate the extraordinary career of Professor Yuval Goren on the occasion of his retirement. We are grateful to the Israel Institute of Advanced Studies and Ben-Gurion University for hosting this event, and to Karen Rechnitzer and Pina Meyerson, who have been working diligently behind the scenes to make this all happen. We also extend a warm thanks. Thank you to Yuval's family, especially his wife Rivka, another wonderful colleague of ours, and colleagues and friends for coming here today to mark this occasion, and to the speakers who are with us from near and far. In such troubling times, it is a comfort to be able to bring people together, and our hearts and prayers are with the hostages, the wounded, and the displaced. Okay. Yuval, as we are told, was curious and passionate about science from a very young age. His fascination with microscopes in particular foretold his future career. Microscopy has always been central to Yuval's work in archaeology and heritage sciences. His search for a reliable, portable, polarizing microscope led him to design his own field microscope, which was patented and produced commercially. Over time, he has also built a collection of historically significant microscopes, including some milestone models used by the pioneers of microscopy, microbiology, bacteriology, geology, and other scientific disciplines. In light of this passion, we decided to title today's event, Discoveries Through the Lens. Yuval's former academic journey began in 1981 at Ben-Gurion University of the Negev, studying archaeology. He completed his MA studies in 1987 with a thesis on the petrography of Chalcolithic pottery, one of the very first studies of this kind in the region. In 1992, a mere decade after beginning his BA, Yuval earned his doctorate from the Hebrew University of Jerusalem. His doctoral research under Professor Paul Goldberg, Professor Itzik Gilad, explored the beginnings of the pottery production in the land of Israel and the surrounding region, researching the technology and typology of protohistoric ceramic assemblages. Yuval's interest in ancient technology, particularly pyrotechnologies, has remained constant throughout his career. Alongside his studies on ancient ceramics, he has produced extensive research on the beginning of plaster technology and metal production in the Levant. In addition to the use of thin section petrography, Yuval's research has embraced chemical methods, including X-ray fluorescence and Raman spectroscopy. It was during his doctoral research that Yuval began to train and work in the field of micromorphology. He worked as a petrographic researcher at the Israel Antiquities Authority from 1989 to 1996, and in 1996 joined Tel Aviv University as a senior lecturer, being promoted to full professor in 2005. His academic vision led to the founding of the Comparative Microarchaeology Laboratory at Tel Aviv University. Over the years, he held a number of prestigious roles at the university, including chairman of the Department of Archaeology and Ancient Near Eastern Cultures and vice dean of the Faculty of Humanities. In 2016, Yuval was invited to join the Department of Bible Archaeology and Ancient Near Eastern Studies at Ben-Gurion University, bringing his journey full circle as he returned to the institution where he first began his academic paths. In Ben-Gurion, he established an international academic program dedicated to the study of archaeological materials and heritage sciences, further enriching the field with his expertise. He has also been a visiting professor at Sapienza University di Roma and an honorary visiting professor and honorary professor of archaeology at the University College London. Yuval's career is a testament to the power of interdisciplinary research, and throughout his decades of research, he has collaborated with a large range of scholars and institutions. One long-lasting and pioneering project, which began in the early 2000s, focuses on the spread of literacy in the ancient Near East. By analyzing cuneiform clay tablets using geoarchaeological methods, Yuval and his collaborators have traced the political and socioeconomic networks of the ancient literate world. This project has included collaborations with Assyriologists, museums, and colleagues across the world in Germany, the UK, France, Portugal, Sweden, the USA, and Cyprus. Yuval's work is distinguished not only by its interdisciplinary approach, but also by its geographic breadth, spanning sites in the Levant, including neighboring Jordan and Egypt, and distant locations such as Crete and even China, as well as the bottom of the Mediterranean. Yuval's ongoing collaborative project with the Institute of Nautical Archaeology, Texas A&M University, and museums in Turkey and Cyprus focuses on international exchange in the Eastern Mediterranean during the 2nd and 1st millennia BCE. This project utilizes mineralogical and geochemical methods in analysis of pottery cargoes and stone anchors in shipwrecks along the Eastern Mediterranean coast. This ongoing study has yielded insights from a number of shipwrecks, including well-known ones like Uluburun, Cape Gelidonia, Kyrenia, and more. Yuval's contributions in the field have been extensive, with excavations at Nahal Kisufim, En-Gedi, Patzael, Zikim Beach, and more. He is a strong proponent of taking the lab into the field, and his work on early metal production is a perfect example. Through combining advanced archaeometallurgical methods with microarchaeology, Yuval has made significant strides in identifying microarchaeological features accompanying metal production contexts. In addition to his approximately 250 academic publications, Yuval's work has had significant impact beyond the scientific community and among the wider public, especially through his expertise in detecting forgeries, a critical aspect of preserving the integrity of archaeological research. His work has been instrumental in evaluating the authenticity of artifacts that have generated considerable interests. Just as importantly, Yuval has mentored countless students, many of whom have continued to successful careers in the field. His legacy is not just in his publications or discoveries, but in the many archaeologists he has guided throughout their careers, a number of whom we will have the pleasure of hearing from today. So tonight, we recognize his outstanding contributions and lasting influence of his work on the field. The presentations we will hear today are just a taste of this work conducted through many years with colleagues and students in Israel and abroad. So we will have today 2 sessions. The first one will be chaired by Professor Alex Van Talking from Tel Aviv University and the Israel Institute of Advanced Studies, and the second session by Dr. Amir Goren from the Israel Antiquities Authority. But beforehand, I would like to invite Professor Gunnar Lehmann to say a few words on behalf of the Department of Archaeology and Ancient Near East, Bible Archaeology.
Department of Archaeology.
Yeah, Department from Ben-Gurion University.
עבדנו קשה לקבל רק את השם החדש. תודה.
Dear colleagues and friends, and dear Yuval, today we gather to celebrate the remarkable career of Professor Yuval Goren as he retires from his distinguished service at Ben-Gurion University. Yuval, whose career his journey, academic journey, spent significant tenures at both Tel Aviv University and Ben-Gurion University. He has left his mark on the landscape of archaeological science. Yuval's contributions to the study of archaeological materials, particularly his pioneering work in petrography of ceramics, have revolutionized our understanding of ancient technologies and trade networks. His meticulous methods and insightful interpretations have guided countless studies and continue to inspire both his colleagues and his students. Beyond his academic expertise, Yuval has been a mentor to many in the academic community. His passion for uncovering the past is matched by his dedication to serving the next generation of scholars, and he provided guidance, and his advice has shaped the careers of many in this room. As Yuval steps into retirement, we reflect not only on his professional achievements, but also on his personal qualities, his integrity, his originality, and his unwavering commitment to truth and knowledge, which also took place even in courtrooms, I understand. While he may be retiring from his official duties, his legacy will undoubtedly persist, also in our university, through his many lives that he has touched. Yuval, on behalf of all of us at Ben-Gurion University and beyond, obviously, we thank you for your invaluable contributions in the field of archaeology and our academic community. Wish you a fulfilling and joyful retirement, knowing well that your influence will continue to resonate in our work for many years. Thank you very much, Yuval.
So, without further delay, just we shall embark on the first session, which is the international one. And I will just say really two sentences that when Yuval started his academic career in Tel Aviv in '96, that was my first year of enrollment as an MA student. And I still recall these classes, and in particular this petrography seminar, which influenced, I would say, my entire career. I did not become a petrographer by myself, but I worked with Anat, for instance, Cohen Weinberger now on a very big project which deals with petrography and AA and other things. So really very dear moments that with Yuval as a teacher, as a mentor, that I still keep in my heart and cherish very much. Thank you very much. The moment you left to Beersheba, it was a very difficult moment to so many of us, but I assume it was a very good moment for Beersheba because they got a scholar of this caliber. So maybe it's, after all, maybe it was a right decision to establish something in Tel Aviv and to establish something in Beersheba. So thank you very much for these beautiful memories and your mentorship. And now, as I said, without further delay, we move to our esteemed international guests via Zoom. Lina, are we okay? Good. So our first speaker is Professor Dimantis Panayotolopoulos from University of Heidelberg. Professor Panayotolopoulos is a professor in classical archaeology at Heidelberg, and his research interests include landscape archaeology, social structures of Minoan and Mycenaean civilizations, sealing practices, visual language, and the interconnections between the Aegean and the Near East. Today's talk will touch on a number of these, and it is entitled Writing History with Seal Images, a multi-analytical approach to the riddle of the Cnossian replica rings.
Okay, thank you very much. I hope that you can hear me, and I will try to share my screen now. Okay, now, can you confirm that you can see the first slide?
Yes.
Perfect. Okay. So first of all, I would like to express my heartfelt thanks for inviting me. It's a great honor and pleasure to participate in this workshop. I'm very sorry that I could not be physically present. And what I'd like to do today is to offer my rather exotic topic as a small token of friendship and appreciation to Yuval for a very fruitful and pleasant cooperation, which now spans almost 2 decades. So, prehistoric archaeologists, in their continuous efforts to elucidate ancient realities, strive to interpret material evidence from past societies and thus effectively to write history through artifacts and images. This, however, is, as we know, not a simple task, as non-textual archaeological evidence is inherently ambiguous, open to multiple interpretations. Such frustrating ambiguity has long challenged scholars attempting to unravel the events in the heyday of Minoan culture on Crete around the middle part of the second millennium BCE. A crucial step towards understanding Minoan history has been the effort to clarify the island's political geography by delineating territorial boundaries. This research objective has been distilled into a fundamental question. During the Neopalatial period, did the Palace of Knossos exert control over most of the island, and perhaps even extending its political and economic influence beyond Crete itself? The main method addressing this question in a culture without deciphered written sources has been, and still is, the thorough study of patterns of distribution, absence, or regional variability in specific traits of material culture, including architecture, wall paintings, pottery, stone vases, seals, etc. In his path-breaking article on the recognition of polities in prehistoric Crete, Todd Whitelaw has once again demonstrated very well how difficult it is to detect in such traits a politically determined material culture distribution, hitting the nail on the head with the following statement, I quote, "The processes involved may be economic, social, ideological, or political, but we have no basis for determining which, individually or in combination," end quote. The lack of deciphered written sources excludes any possibility for verification. In other cultures and other periods where such a possibility of verification exists, it becomes apparent that patterns of distribution, absence, or regional variation in the material record may conform with political processes, or they may not. For example, a consistency between material record and history can be observed in the general lack of imports or exports between the Greek polis and Persia in the early 5th century BCE, the time during and after the Persian Wars. Yet, there are also examples of the opposite. The fact that between 430 and 420 BCE, that means during the Peloponnesian War, Attic red figure pottery was more popular in Corinth than Corinthian red figure does not in any way conform with the political situation during the dramatic period of this war, when Corinth was Athens' most fierce adversary. This very telling example demonstrates how problematic any equation between pottery distribution and political affiliation may be. There is, however, one class of artifacts that seem to possess a higher hermeneutical value than the rest of the material evidence: the nodules. This technical term stands for the clay objects that carry seal impressions in the Aegean. This is the equivalent to bulla in the ancient Near East. The unique significance of nodules is based on a simple argument. Nodules cannot be related with commercial exchange since they fulfill their function only within a closed administrative network. This assumption is mainly, yet not exclusively, based on following observation. As we all know, there is a substantial body of archaeological data relating to commercial exchange within and beyond the Aegean, and within this very rich field of evidence, nodules with seal impressions are almost totally absent. despite the intensive trade contacts between the Aegean and the Eastern Mediterranean, there is not a single Aegean nodule in Egypt or the Near East, and on the other side, none Near Eastern or Egyptian sealings in the Aegean. Furthermore, within the Aegean, and despite the extensive commercial exchange between different Aegean regions, traveling nodules are virtually absent. And the same applies also to the Near East. To make this crucial point more clear, it seems that in the late Bronze Age and beyond, sealing fulfilled its function only within a closed administrative system in which goods were produced, circulated, and stored without changing hands. In other words, without changing ownership. And this basic premise of mine is in contrast with what David Wengrow assumes because he sees seal impressions as a commodity branding, but there are also other colleagues that have expressed in a very critical way against this hypothesis. This is, of course, not at all surprising, since the effectiveness of the entire system was based on the, at least theoretical, capability of the controller or the end user to identify the provenance and, more important still, the authenticity of the sealing. This was possible only within the confines of an administrative system. According to the evidence at hand, it seems apparent in the late Bronze Age that the person or institution purchasing commodities did not care whether these commodities bore the producer's or merchant's sealing. If sealing and commercial exchange are not compatible with each other, then nodules, and especially their interregional distribution, cannot be linked with a pattern of purely commercial exchange, but instead reflect the operative scheme of an administrative or political institution. From this background, the group of traveling nodules, which were sealed by the so-called Cnosian replica rings in Minoan Crete and beyond, is quite exceptional. The term Cnosian replica rings refers to 26 nodules discovered on 5 widely separated Cretan sites, and this was the great surprise a couple of years ago, even outside Crete, in Akrotiri on Thera. The exceptional feature of this group is the fact that nodules found at more than one site were stamped by the very same gold signet rings, 4 in total, and you see them on this image. The most notable case of the entire group represents a ring with one of the bull leaping motifs, which was impressed on 7 nodules found in 4 different sites: Klavokambos, Agia Triada, Gournia, and Zakros. Most of these nodules sealed tiny pieces of parchment or leather, which were wrapped and tied up with fine threads to form sealed parcels. The modern silicone cast, which you see on the right, of the nodule's rear side, clearly indicate that these tiny folded parcels could not have contained anything. An experimental approach, both by Maria Anastasiadou and Yuval himself, shows here that the only logical inference is that we are dealing with written messages. And you see here the nodule and the folded leather or parchment containing a very likely a written message. In the last decades, discussion of this absolutely singular case of the interregional distribution of identical seal impressions has been controversial, with scholars who interpret them either as an indication of a Cnosian centralized system versus those who questioned their Cnosian provenance, thus supporting the idea of a balanced commercial network and therefore regarding these nodules as clear evidence for a sealing practice in the context of market exchange. Yet, the incompatibility between sealing and commercial exchange weakens, in my view, the later assumption and forces us to look whether we can strengthen the former one. And this is where Yuval comes into play. This was the main working hypothesis for our project, aiming at a multidisciplinary analysis of this group, which Yuval and I undertook mainly between 2005 and 2008 in two sequential stages. The first stage included steadfast microscopic observations with the aim to verify the community's opinion that all these feelings were not lookalikes, similar to each other, but impressed by the self-same rings. The microscopic analysis by Yuval produced, however, a quite shocking result. The seal impressions were same but different. In all cases, as Yuval demonstrated, this difference referred to minute details. You see here three examples, three seal impressions from Aie Triada and Sklavokambos, demonstrating where the dissimilarity lies. It can be seen, you see here a horse, and you can see the minute difference in the direction of the horse's head. Here it looks upright, and here in the two others is horizontal. During a visit at the archives of the corpus of the Minoan and Mycenaean seals, back then in Marburg, in 2006, and after the first embarrassment of its directors, Ingo Pini and Walter Müller, the problem of these minute differences was easily solved with an experimental approach employed in modern plasticine impressions. It became clear that all Minoan sealings of each subgroup came from the very same signet ring, yet they demonstrated minute dissimilarities as the result of the sealing procedure, in the course of which the delicate twisting both of the seal ring and the wet clay lamp produced slightly different seal impressions. A few years later, and after the transfer of the corpus of the Minoan and Mycenaean seals from Marburg to the University of Heidelberg, we could address this problem with forensic methods, first with 3D laser scanning, and recently with an algorithm which was developed by Bartosz Bokac at the Heidelberg Interdisciplinary Center for Scientific Computing. The algorithm is based on previous digital approaches to correspondence matching and image deformation, with a basic objective to produce grid visualizations of deformation in order to map different handles and perhaps even different individuals. This is a work in progress, so we focus on the minute difference between identical seal impressions in an attempt to detect different hands, and perhaps that means different individuals. The second stage of our project included the extraction of minute samples from most of these nodules, using, among other analytical methods, the scattered petrographic analysis that Yuval developed for the sampling and analysis of delicate clay items, among which were also the famous Amarna tablets. The samples taken from 16 nodules of the Gnossian replica rings group and 21 related pieces from the same context were examined under the petrographic microscope, the environmental scanning electron microscope, and the attached energy dispersive spectrometer. And based on the mineralogical and chemical data, the raw material of all the examined specimens is readily identified as derived from the so-called red clay deposits, which are in fact the terra rossa soils that are exposed in many localities of the island. These clays vary, though, in different parts of the island by their mineralogical and chemical composition, so that their provenance can be detectable. And this was the merit of Yuval's work. The basic result of this analysis is that the raw materials of almost all nodules we have examined are in agreement with those known from north central Cretan assemblages, making thus the region of Knossos, and that means specifically the palace of Knossos, their most likely place of origin. There were only 3 outliers, 1 nodule from Agia Triada and 2 nodules from Akrotiri in Thera, which were made from clay from the Messara area in south-central Crete. The reasons and conditions of their production are as yet unknown. Based on these results, it seems fully justifiable to make the inference that we deal with Knossian nodules whose distribution was associated with a closed Knossian network. And this is a perfectly neutral term. A network which operated on an interregional basis on Crete and even beyond the island. Such a network would, furthermore, be in accordance with a particular type of these nodules, which seem to have sealed not commodities, but, as I told you, written messages. Now, is it possible to define the character of this closed network more precisely? Or, to put it more bluntly, does the interregional distribution of nodules, which were most probably stamped at Knossos with local golden signet rings, necessarily imply that the places where they were found were agencies or branches of a Knossian political or administrative institution? This assumption becomes very critical in the case of Akrotiri. Do we have to accept in this case that the extent of Knossian political or administrative control reached the island of Thera, modern Santorin? Well, not necessarily. Between the 2 extremes, option A, nodules as evidence for a balanced commercial network, as has often been suggested over the past years, and option B, nodules as evidence for Knossian hegemony, there is a third option, which I would favor here. And this third option seems to do better justice to our hard facts. On the one side, the incompatibility between sealings and trade, and on the other, the general impression that one gets from Akrotiri's material culture, since this thriving community could evidently adopt Minoan fashions as easily as it could reject them. So the general impression is that the Akrotiri community was independent from Minoan Crete. According to this third option, which in my view provides the most plausible explanation, the Minoan nodules from Akrotiri were kept in a Knossian trading post or emporium, which represented a far outpost of Knossian administration, without, however, implying that the place in which it was established, namely Akrotiri, was under Knossian control. This hypothesis is strengthened by the well-known evidence relating to the Middle Assyrian trading colonies in Anatolia, which document Assur's wide economic reach, but not Assyrian political or administrative control over parts of the Anatolian territory. In the most prominent of these Assyrian trading posts, Karum Khanes, modern Kültepe, the Assyrian merchants who exchanged textiles and tin for silver and gold communicated with the Assyrian capital and their families via letters, and it is mainly this correspondence that was sealed. If we now accept that the Minoan nodules in Akrotiri sealed letters, stirring the exchange of information between the Knossian center and its trading post, information which was classified or had to be authorized through sealing then we have a very close parallel to Kultepe's silk correspondence. But even if the Minoan nodules did not seal any proper correspondence, but were in some way related to the shipment of commercial items, the suggestion of a trading post is still possible. In this case, there is no contradiction to the aforementioned general rule that sealing played no role during the moment of commercial exchange, since the sealed Cretan objects arriving at the Gnossian trading post at Akrotiri fulfilled their function strictly within the orbit of one and the same administrative system, and that means before the actual transaction, namely the moment in which the commodities changed hands and were delivered by the Gnossian merchants to the Theran merchants or end users, the consumers. And I'm trying to visualize this situation by referring to the ninth scenario or mode of trade, according to Colin Renfrew. And I'm using his graph. And you see here, B is Knossos. B with this accent is the Gnossian trading post in Akrotiri. And A is the local population of Akrotiri. The transaction is taking place here, but the Gnossian nodules fulfilled their role only during the transport of this of the sealed goods or correspondence from Knossos to the Gnossian trading post in Akrotiri, and not after that point, namely at the very moment of exchange between the Gnossian trading post and the local population or the local merchants. If we now turn back to Crete, the Gnossian presence, again, a very neutral term, in each of the nodules find places, Agetriada, Sklavokambos, Gournia, Palekastro, and Zakros, could have taken different forms, leaving the option of a stronger Gnossian administrative involvement and perhaps even Gnossian political influence open. This is definitely not the place to delve deeper into this complex issue. At the end of this very brief survey of the relevant evidence, it suffices perhaps to say that Yuval's contribution to this persisting problem of Minoan archaeology has been decisive. By looking through his lens and by combining in a masterful and innovative way different analytical methods, he helped us to get as closer as it gets to a Minoan history of the Neopalatial period on Crete. This extraordinary accomplishment merits our deepest and boundless gratitude. Thank you very much.
Thank you very much, Professor Panagotopoulos. We have a few minutes for questions, if we have any from the audience. Questions, comments? It seems that you convinced everybody with your theories, and I'm in particular very see it very favorably, the idea of the Gnossian maybe more hegemonic role during the Neopalatial period in particular. I think it was less emphasized in the scholarship, and now with these studies that you demonstrate, I'm even more convinced that Knossos had a leading role, at least in the as I said, in the Neopalatial period. So really waiting for continuation of these fascinating studies. Thank you very much.
Thank you. Thank you very much.
And now, adapting the metaphor of traveling nodulus, as a traveling nodulus, we will move to Central Mediterranean, to Professor Gilberto Artioli, who is a professor of mineralogy, crystallography, and material sciences at the University of Padova. As part of his research, he applies techniques from material science to archaeology, cultural heritage, and also works on provenancing ancient ceramics, metals, etc. His talk today is entitled Following the Evolution of Copper Age, Bronze Age Metal Circuits in the Central Mediterranean. Professor Artioli, please, the stage is yours.
Thank you very much. Can you see the slides? Can you see the slides now? Okay, good. Well, thank you very much for inviting us. It's a pleasure, even if in remote, to honor Yuval. And I hope that a little bit of what I'll be saying will be merged with the investigation we are carrying out for the Gassolian chalcolytic. So what I try to do today is to summarize the data that have been multiplied in the last 10, 15 years on the Central Mediterranean. Of course, we started with the local, metal evidence in northern Italy, and then we are trying to link it with the nearby, regions. And I'll try to make a summary, which I wanted to do for a long time, and this is a good opportunity. So, starting with the Copper Age, I will show this Eupedia maps just to connect the crude metal data with the overall dynamic also of the cultures and population, although we might discuss some of the details, of course. And I will use the Italian chronology, of course. And the Copper Age, in Italy started from, the Rinaldone culture, more or less, 3600 or so, until 2200 before Christ. And I will start with the Copper Age and then move to the Bronze Age a little bit. And the most recent things that we did is an assemblage of a lot of axes, a few other items, spanning the full Copper Age. We presented last year in Falun. But I think for the first time, we were able to define very clearly the metallurgical phases starting from the very late Neolithic to the end of the Copper Age. Many of these items are undated, very few of them, but they cover more or less the span of the Copper Age as we defined, and allow us to define the different phases because there are very neat provenances that appear from the isotopic observations. So if you group all the data of the more than 60, 70 items that we analyzed, there are clearly three major sources of copper, plus a few other items that I will not discuss here, but I think they are just out of chronological order. And the three isotopic regions that are well defined are clearly the Balkanic one, the green, the Tuscanian one, central Italy, in gray, and then the red one are the Alps. And we were in the beginning very confused by the chronology appeared from the shared typology, but by regrouping following the fixed point of the well-determined items, we think that there is a phase one of the metallurgy in northern Italy and nearby regions, and that is just stemming from the Balkans. So there is basically no local production, but the items are arriving from the developed metallurgy of the Balkans, especially Bulgaria, but Serbia is cropping up very neatly in a couple of items. If we compare our data with the spread of the oils from Serbia and Bulgaria, and all the other oils from other projects that we investigated in northern Italy, it is quite clear that there is this unique provenance of the metal for the whole lot of the end of the Neolithic and the early, 4th millennium before Christ. So Balkans are the only evidence up to, the local cultures, which are, the Copper Age cultures of Rinaldone and Remedello. Again, I'm relying on one of these maps to show that these are the two major cultures developed in Italy, in the second part of the 4th millennium. And very interestingly, if we start looking in more details at these data and items pertaining to these two cultures, Tuscany comes up very clearly. So most of the items are from Tuscany. This is the second phase. And it is very interesting that copper from the Tuscany actually was traveling at that time rather far, up to Tyrol, for example, for the Iceman that has exactly the same signal. But other items have been found now in southern France and Switzerland with exactly the same signal. So Tuscanian copper was traveling all around the Alpine region at that time and beyond. Very interestingly, if we compare objects farther north, which is the Mondsee and the Riesbusch copper reaching Scandinavia, this is actually also related very much to Bulgaria and the volcanic copper. So the volcanic copper was reaching all the northern Italy at the same time, northern Europe, at the same time that actually Tuscanian copper was covering northern Italy. So there is a sort of split in the second half of the millennium. Tuscany was covering what was supplied by the Balkans, the first part of the millennium, and then the volcanic copper was flowing north. And it's very interesting that also, along with the major source of Tuscany that you can see in the plot for the typical Rinaldone objects, there are a few others which are actually coming from in the more west. It's the Western Alps and the southern France, we believe. So there is the majority of the copper diffusing is essentially Tuscanian, but down to the very late stages of the Remedello culture, which is 2800 before Christ. But there are a few items that are actually of imported copper, which is, I think, very interesting. So we do have this split in the second part of the 4th millennium. The Balkans are going to North Europe. Tuscany is flooding central and northern Italy and a little bit beyond, together with a few, minor components coming from the west. And then, of course, there is the, further Bell-Beaker event spreading from this 3rd millennium, starting from 2500 or so, down to the end of the Copper Age that we mark at 2200 before Christ. And this is very interesting because this is clearly a phase where we see the Alps coming in. So the Bell-Beaker, whoever they were, they really started the Alpine metallurgy, and that was a prominent, process and the mass production, as we have evidence not only in the items, which are, covering everything we find in this period around the Alps and the northern Italy, but also we see them in the Alps that were before volcanic. In Switzerland, many of the items were coming from France, but also from the Alpine region. This needs to be redetermined a little bit. And most of the items typically of this period are fully Alpine, apart from very few, like this ring is probably coming from the Balkans again, but most of the items are clearly Alpine. This is probably one of the ords that signals the starting and the diffusion of alpine coppers in the region from the Italian side and elsewhere. And we have the evidence also of the production because of ample evidence of slags all around the Tyrol, South Tyrol and the Trentino area. So Southern Alps are filling basically the copper supply for most of the last part of the Copper Age up to the transition. And now we are following the transition. We have a couple of sites. So that these are the three major phases that we identified that were very confused before our investigation, I think. The transition I was saying, we can follow that we have two sites. One is Nogarole Rocca in the Po Valley, south of the Lake of Garda. It's a typical bell beaker. And we see both signal, of course. The Alps continues and some items of Tuscany. So the two sources coexist in the very last part of the Copper Age in the northern Italy. And we expect that going south, the Tuscanian signal increases. And this is readily determined in the Acerra and Ostiglia sites and near Vesuvio. Acerra is a very interesting site. It had the same fate of Pompeii, but 2,000 years before. It was buried by the volcano, so we do have ample evidence of the society there, and we are paralleling the investigation of the metals with the isotopes in the bones. And if you see the items in Acerra and Ostaglio, you see the prevalence of Tuscany, of course, as a source, as you see in the north. But then you do have a bunch of other materials which are clearly not from Tuscany, although the models are from the north. We think that maybe Sardinia or Iberia, and maybe a couple of items from the Balkans. So we think that there are different sources reaching south of Italy, where with the prevalence of the Tuscanian copper that was flowing south, but also a few items exchanged through different networks, clearly. So it's very interesting to see that Tuscany almost disappeared in the north and during the last part of the Copper Age, but then it's coming back in the early Bronze Age, and we evidence, we do have a fair good number of objects from the early Bronze Age, both from the Alps, the pile welling, and other cultures more in the Apennines. And both sources are really evidence. Both the Alps and Tuscany continue for the whole of the Bronze Age. And again, you can see that these are a certain number of items that we group together. The Alps are dominant with a few items coming maybe from across the Alps. And then we move into the Middle Bronze Age. We do have the development of a typical culture on the Apennines and the Terra Mare cultures, and more the Nuragic civilization flowering. And if we start looking at the objects in the Middle Bronze Age, in the north, we see still the prevalence of the Alps very clearly, but a few items, especially precious items like this crown, are coming from the north, like the Slovakia and Mittelberg, which is very interesting. There were clearly contacts in the Middle Bronze Age towards Central Europe. And if you look at the swords, again, the local swords are from the Alps. A few are from Tuscany. And if you start looking at the swords and the other items flowing north, then you see that this was the collaboration with the Scandinavian group of Melheim and Johan Ling and others. you can clearly see that there was a huge flow of copper from the Alps as a major source into what was the period 2 and 3, and especially 3 and then 4 of the Nordic Bronze Age. And this was a neat discovery that good part of the copper from the Alps in the peak of production was going north into Central Europe. But there are amazing things, so like the Viverone culture in it's a lake dwelling in the western northern Italy. It has no signs of the Alps at all, and it has connections towards Central Europe. So the Alps were producing a lot, was flowing north. There were connections with Central Europe, and even more connections we see in the western part of the Alps that were not producing yet at the time. So that's very, very interesting, and it shows that there were some kind of connections from the west to the United cultures in the north. So it was actually a surprise that no Tuscanian or South Alpine copper are present in this extensive bronze hoard of the village. And going towards the late recent Bronze Age, then we see Alps everywhere. In all the Po Valley, in the Alpine region, and that is the dominant flux. So most of the copper was going north, but a good deal of copper was also used for the local cultures in the valley. And yeah, you can see that very well. I'm not going into the details. It's very interesting that after the collapse of the Terravare culture and when Fratesina takes over along the coast, then most of the copper is actually flowing no more north. There's a collapse of the trades in the Central Europe. It flows south through Fratesina and is reaching far places, as we will see, because if we think that, like Pierce was proposing, that Fratesina is really hub from the flow of a lot of materials. There were ivory imported and amber and copper exported all around the Mediterranean. Then we see that quite a bit. Mayhofer found a lot of alpine copper along the Balkans. So we are reversing, in the late Bronze Age, the flux of copper towards the Balkans. We find, again, Jung and Hofer found, a good deal of alpine copper in Punta di Zambrone in Calabria, and very interesting items. And this is the Alps found in down far south. I was expecting to see more Tuscanian copper. There is some, but many alpine items are there. And now we are investigating a few sites in Sicily, and we do see that lead is clearly coming both from the Aegean in the Lorion and from Sardinia. And we think that, although some alpine items and Tuscanian items are there, most of them don't fit with the Alps or Tuscany. And we think that Sardinia is actually supplying copper as well as lead, which makes the story very interesting. So, connection with the culture in the north, Hallstatt, that was the period where alpine copper is flowing to the Balkans, and of course Mycenaean, in the east, and Rajic civilization in the west. So in the copper, just as summarizing, in the Copper Age, we have a simple three-phase with very little exceptions. Balkans through a very defined period of copper supply that will supply most of the items all around the peninsula. In the Bronze Age is a little bit more complicated because we see, the French and Western Alpine copper coming in. In the north, we see the Alpine copper going into in the Balkans. We see Sardinia interacting with the central Italy in the Nuragic bronzes, and with Sicily, with the data I just showed, Sicily interacting with the Eastern Mediterranean. And of course, the whole picture is more complicated and dynamic. And not taking into account the fact that we know that the tin was coming in through different routes. And in the Bronze Age, Middle Bronze Age, we already have tin coming from the eastern source and the western source in Italy. There is clearly, we have seen copper flowing north up to a certain point of the collapse of the trades, and there is certainly, Cypriot oxide ingots flowing eastward, reaching Sardinia and farther on southern France. So that the picture is clearly very nice. I will end up with a couple of things which are usually not considered. We have seen in at least two places very clearly that in the very late Bronze Age, we do see a sort of recycling and remelting, so that the localized hoards for the objects have a sort of average, homogenized composition, both chemically and isotopically. But then when they need the fresh copper is coming from elsewhere. And we see very clearly, that Alpine copper flowing into Eastern Friuli and Slovenia. We see very clearly Aegean copper in the ingots coming into Laonacien in southern France. So it's like you have continuous recycling of homogenizing of the metals, but that flow, the ingots and the objects have a different composition, and the fresh copper is coming from elsewhere, which I think is very, very interesting. And I stop here, and I hope that next story will connect the Eastern Mediterranean with what we are doing with Yuval. And I thank you very much.
Thank you very much, Professor Ortioli. Any questions? Am I not going to ask about copper circulation?
Amazing picture, highly complex, and I am curious how it all fits with the Eastern.
Yeah, I was thinking all the way. Where are we? We think that we are so central and important. Apparently, we are just outside of this map, yeah, with the Timna and Feinan. So where are we? I have a question. Maybe it's I don't know if it makes any sense, but recently there were many publications about all these migration attested via genetic analysis for Bell Beaker's cultures. Does it affect in any way your theories about metal dispersion and etc.?
No, not really. I mean, we were considering now the Yamnaya, event as linked with the flow population, but I mean, the sources of copper are independent of that. They were just really exploiting heavily all copper sources, available, especially in the Alps.
Thank you. So, if we don't have any question from the audience, thank you. Elliot. Where is the tin come from? On the map, it was from the UK, no?
Yeah, we have evidence from lead isotopes that most of the tin was coming from the Atlantic province. I wouldn't say Cornwall because we can hardly distinguish Cornwall from Normandy and Iberia, but from the west, from the Cassiterides. But there is also a couple of items of tin that are clearly have a different signal, and we think it is the same tin coming from the east. So that was reaching and merging in the Mediterranean, central Mediterranean.
Okay, thank you very much for this very exciting presentation. And our next speaker is Professor Sabrina Grassini. She's a professor of applied chemistry within the Department of Applied Sciences and Technology at the Polytech Uni at Turin, Torino, in Italy. And she deals with a variety of topics, studies of degradation processes of metallic artifacts and development of strategies for restoration and conservation, innovative technologies for protection of metallic artifacts, digitization techniques, electrochemistry and corrosion studies, etc., etc. And today, Professor Grassini will be discussing the joint project for international research, tailored strategies for increasing cultural heritage resilience. Please.
Good afternoon. Thank you very much for your kind introduction. Just try to share the screen. So I hope it works. And I hope you can see the slides. So first of all, I would like to thank you for inviting me to participate even remotely to this workshop to celebrate our colleague, but also our friends, Professor Yuval Goren, we are very grateful to him, to the very fruitful cooperation we had in the last year. And I try today to summarize the activity we did together in the last almost 8 years in the fields of cultural heritage and to try to highlight his important contribution in giving us the opportunity to increase our competencies, also considering the archaeological context or the artifacts we are studying. I would like also to bring to you and to you all the greetings and thanks for our research group in Politecnico di Torino. We are a multidisciplinary group of 2 different departments. As you kind of introduced me, I work in the Department of Applied Science and Technology, and our colleagues in my department has different competencies in chemistry, electrochemistry, mainly devoted to corrosion and protection of metals, and also material science and engineering, and with particular interest in the cultural heritage field. We work mainly on corrosion and protection of metals. Corrosion is the interaction between the material and the environment. That is a reaction that you cannot stop from the thermodynamic point of view. So it's something that we have to study in terms of mechanism, also in order to understand which are the interaction with the different aggressive agents in the environment. So we benefit of the cooperation with the colleague of the electronic department in Politecnico di Torino. They are electronic engineering with expertise in the developing of sensor and measurements, probe and methodologies. So this is a very important cooperation in order to try to correlate the corrosion of the artifacts with the environmental condition. And then if you think about towards conservation and resilience of cultural heritage, the interaction with the conservator and restorator is of course a very important point. So we have a cooperation with the Conservation and Restoration Center located here in Venaria Reale, a small town very close to Turin. They are one of the main institutes in Italy devoted to conservation and restoration of different kind of multimaterial artifacts. And so the cooperation with them is very important because you can also have the point of view of the people who have to maintain and try to find strategies for preserving the artifacts. And all the entire group benefits of the cooperation with Yuval because it's also very difficult in many cases to analyze the artifacts and knowing which is the archaeological context in which the artifact is being produced and degrades as a function of the interaction with the environment. So the interaction with the archaeology is a very important and crucial point. So I just try to summarize what we did with Yuval in almost last 10 years. The cooperation with him started thanks to two educational projects, the Erasmus Mundus Master and then the European Doctorate in Archaeological Cultural Heritage Material Science, ArchMat and the ArchMat. In these two projects, my professor, my colleague, Angelina was deeply involved. And so thanks to her interaction with Yuval, we have the possibility to create a fruitful cooperation between our group. The results of this activity lead us to participate to a project call, supported by our university. The call has a final meaning to strengthen the international cooperation in research in different topics. So we were able in 2018 to present a joint project between Politecnico di Torino and the Department of Archaeology of the Ben Gurion University of the Negev to create a group and a strong partnership in conservation of cultural heritage. This was very important from our side because Politecnico would like to encourage and support incoming and outgoing mobility of students and staff between our two universities. So we had the opportunity to work with Yuval both in Israel and in Italy. And this, of course, is very important for the exchange of knowledge. Thanks to Yuval and his effort, we were also able to submit an Erasmus partner countries program for creating opportunity of mobility at the different level from student, bachelor degree and master degree, and also PhD student between Polito and BGU and vice versa. Thanks to the cooperation with Yuval, we were able to sign this agreement, which give to our student and to the student of the Ben Gurion University to exchange knowledge and also exchange study visit involving students in cultural science and engineering, but also in material science and metrology. So most of the topic on which we are involved and allow to create a multidisciplinary approach also devoted to cultural heritage conservation. So we thank you all very much for this opportunity to sign this agreement. It is still active and it is also recently renewed. So his activity as a mentor for our student and our PhD student will be maintained also in the next year. So just to summarize, which are the main objective of our internalization of research project, entitled Tailored Strategies for Increasing Cultural Heritage Resilience. It is a bilateral project and with different objectives. Of course, the projects aim to increase the partnership and the joint research activities between our group, between our department and the Department of Archaeology and the research group of Professor Goren. We focus, since we are electrochemists and expert in corrosion, the research activity and the exchange of knowledge, mainly on metallic artifacts, mainly copper-based alloy, for which we are interested both in the study of the corrosion mechanism and in the development of tailored strategies for their protection and long-lasting conservation. Thanks to the cooperation with the archaeology department, we have the opportunity to consider also which is the archaeological context, and thanks also to the interaction with Yuval, we have the opportunity, for example, to visit the restoration lab of the Israeli Museum in Jerusalem, and so also to discuss with the restorers which are the main problem in the conservation of the artifacts, and also developing possible employed solution for the future, and also considering different requirements in the exhibition in order to develop good strategies, also to involve the public and increase the fruition of the artifacts. Another important goal of this project was to carry out a joint educational activity. Thanks to the European doctorate program, but also thanks to the foundation that financially support these bilateral projects, our PhD student has the opportunity to come to Israel and attend, for example, to this important summer school, which was held in July in 2010. And this is very important because they have the opportunity to consider which are the effects of the analytical procedure we always did on real and precious artifacts, and also to benefit of the idea of Yuval to bring the lab in the field, so to be in the archaeological site doing technical analysis as we always do in our laboratory. So then, thanks also to the signature of the Erasmus agreement, we have the opportunity to put together the two projects and to increase the opportunity of mobility between our university staff and the student exchange. So we have also the opportunity to work with Yuval in our laboratory and in his laboratory in Israel. These are some pictures we taken during the study visit of Yuval in Torino in 2019, and also during our visit a few months later. So we have the benefit to see the archaeological artifacts, to collect all the archaeological information, and we can benefit from the exchange of knowledge and also of analytical techniques in order to have a better idea in the new strategies that can be used to study and also to protect cultural heritage, with particular attention to metallic artifacts. And finally, another important goal of this project is the opportunity to increase the dissemination activity and transfer of knowledge. So we have the opportunity to submit and present together some contribution to the International Metrology for Archaeology Conference which was held in the last years. Here are some pictures of the conference held in Florence in 2019, where we have also the opportunity to present some demonstrating activity and trainings on Raman spectroscopy and also other portable and non-invasive technique like electrochemical impedance spectroscopy, which can be used to analyze the artifacts in a non-invasive way and to study the corrosion mechanism. So moving to the scientific part of this project, thanks to the cooperation with Yuval, we had the opportunity to study some Roman coins coming from the archaeological site of Raqqa 454, close to Beersheba. Probably you know better than us the characteristics of this archaeological site, and to investigate, mainly by Raman spectroscopy, X-ray fluorescence, the corrosion products, in order to understand the corrosion mechanism and develop some idea for the future conservation. The archaeological site of Raqqa 454 is the archaeological site you can see in this slide. It was situated near the border between Judea and Nabatea, and it dates back to the Roman period, more or less from the 1st century to the Bar Chava revolt against Rome. Thanks to the excavation performed thanks to a collaboration between the Department of Archaeology of BGU and the Israel Antiquities Authority. In particular, we would like to thank Professor Peter Fabian for his also contribution in our study and for giving us the opportunity to analyze this nice set of ancient coins. In the site, many artifacts were found. In particular, since we are interested in the conservation of metal, we focus our attention on a set of Roman copper-based coins. Some of the coins are here shown in this slide. As you can see, are mainly coated by corrosion products green and blue and some sediments. So it's very interesting for us to study the corrosion mechanism, the long-lasting corrosion mechanism in soil. So on the basis of the different morphology of the surface and of the corrosion products, we select 24 artifacts for our study, 23 bronze coins, and one bronze pendant that you can see here on the left on the bottom. The objective of our study are mainly four. We are interested in the characterization of the alloys to obtain information on the correlation between the alloy composition and microstructure and the degradation mechanism affecting these artifacts. So we deeply investigate the corrosion products in order to confirm and to have information on the corrosion mechanism. Thanks to the competencies of Yuval in petrography, we can also correlate, which is something not frequent in corrosion study. We can also correlate the corrosion reaction with the microenvironment and the characteristic of the soil, of the sediments in which the artifacts have been excavated. And this information we try to analyze of the artifact using non-invasive techniques in order to assess the artifact conservation state. Generally, the metallic artifacts reach an equilibrium between the surface and the soil when they are buried in soil. And in many cases, after the excavation, exposing the surface to humidity and oxygen can deeply accelerate the corrosion mechanism. So it is important to understand if, in particular for bronze artifacts, the corrosion product layers, which is called the patina, has a protective effect towards further corrosion, or if in the patina there are particular aggressive agents which can increase the corrosion reaction till the complete degradation of the objects. So in the Ben Gurion University, it was possible to perform a very deep campaign of X-ray fluorescence measurements to characterize and to obtain information on the alloy composition. As you can see here, just a table summarizing the main results. Most of the coin are composed by copper, lead, and tin. In some cases, the concentration of lead is very high. In this case, this is also an important information to study the degradation mechanism, since the microstructure is generally composed by a copper-rich matrix. And you can see here in the image at the scanning electron microscopy, you have a distribution of lead globules inside the copper-tin alloy. After we focus our attention on the long-term corrosion in soil, which is of course related to the microclimatic condition, but also mainly with the soil chemical physical properties, content of oxygen and CO2, moisture content, temperature, pH. pH is an important effect because independence of the pH interval, you can see the formation of corrosion products which are not soluble, and so what we call a corrosion patina, which is characterized by the same crystal lattice of the alloy. So it's something that is a corrosion products that crystallize on the surface and remain attached to it and form a protective layer which protect the metallic interface against further corrosion attack. This protective capability of the patina is mainly affected by the presence of aggressive agents in soil, in particular by the presence of chloride ions, which can react if the oxygen and the water level is high, and so makes this patina unstable. They also, as we discuss later, as a very dangerous effect because they create autocatalytic reaction which accelerate the corrosion attack. So in order to characterize the corrosion mechanism, we take advantage of the competencies of Yuval in petrography, which give us the opportunity to learn how to correlate the corrosion with the microenvironmental condition of the sediment in which the artifact is excavated, and also with the anthropogenic activities. This, even if it's not discussed in detail, just some information about the composition of the soil, thanks to the analysis that Yuval did with his microscope in our lab during one of his visits in Torino. It was a silty and calcareous matrix where you can see some quartz sand in grade, but also fragments of pottery and bricks crumbs, slag, and so on. So a very complex microenvironment and we are still investigating which is the effect of this very complex matrix on the conservation and the corrosion degradation of the artifacts. Regarding the corrosion products, we investigate their composition by means of Raman spectroscopy, and we try to identify which are the main composition of the corrosion layers. First of all, we have to optimize the condition for the Raman analysis in order to be less invasive as possible. This is a requirement very important when you analyze ancient artifacts. Thanks to the Raman spectroscopy measurement, we were able to identify on the artifact the presence of atacamite, copper hydroxychloride, which is polymorph clinoatacamite, which are the main corrosion products, usually colored in green and blue, which are found on the artifacts after burial due to the presence of chloride ions in the soil. We also use a statistical approach based on the principal component analysis in order to recognize the different patterns in the Raman spectra and support and help the identification of the different corrosion products. The PCA results allow us to put in evidence the presence of two clusters. 4 of the analyzed sample belong to a group which has a different characteristics from the other, and also a different presence from the quantitative point of view of the corrosion layer on the surface. At the end of this investigation, we identify mainly the presence of atacamite and clinoatacamite, so we were able to confirm the degradation mechanism, which is a classical degradation mechanism that you can find on copper-based alloy. The interaction between the alloy and the environment leads to the formation of a thin layer of cuprite that grows immediately at the interface between the metal and the environment. Then, due to the presence of chloride ions, the degradation goes faster. Chloride ions react at the metal corrosion layer interface to form xanthocite, copper chloride, which is responsible of a cyclic copper corrosion, the so-called bronze disease. In fact, xanthocite reacts very fast with oxygen and water, forming cupri hydroxychlorides, what we observe on the surface, the green-blue corrosion products. And also, this reaction leads to the production of chlorhydric acid, which again react at the interface between the corrosion products and the metal, leading to a sort of self-sustainable reaction with the formation of xanthocite in a cyclic process till the artifact is completely destroyed. So this is a very important information and put in evidence the necessity to remove copper chloride from the patina. This is not exactly a simple treatment to be carried out, or to protect the artifacts from the interaction with the environment, for example, in an inert atmosphere. So we hope that these results of this chemical and morphological characterization can help the restaurant and conservator to define which are the most appropriate restoration strategies and also exhibition strategies in order to preserve the artifacts as long as possible. So this is just a brief summary on what we did in cooperation with Yuval. So we would like to thank Yuval again for this very fruitful cooperation we did, and we hope to have the opportunity to meet him in person as soon as possible. And thank you all for your kind attention.
Thank you very much, Professor Grassini. We have time for one or two very short questions, if you have any.
I can.
So if not, thanks again for this exposition of this international network, truly international network, where Professor Goren served as one of the central pillars, actually. And now, with your permission, in Italy, we shall move to coffee break here in Jerusalem. Next time, maybe in Padova or in Turin, or you will come to us. So thank you very much again. And let's be back. Let's try be back here in the class in the room around 5.
את רשות העתיקות לאקדמיה, אבל נוכחותך עדיין מורגשת במעבדה, כשמדי פעם מתגלים במגירות רכיבים אניגמטיים, ובעיקר האלתורים המוכיחים שמחקר טוב לא תלוי תמיד בתקציב, אלא בעיקר ביצירתיות. כי באמת מי עוד היה מעלה על דעתו להשתמש בזכוכיות מהדוד שמש שלו כדי לייצר שקפים פטרוגרפיים, לייבש שקפים בפן של השיער, או להפוך נייר צלוטפ לתחליף מאולתר לפלטת למדה. יובל, ההשפעה שלך ממשיכה ללוות אותי ואת קהילת חוקרי הפטרוגרפיה, והיום יש לי הזכות לעצור לרגע, להוקיר, להגיד תודה. תודה על הדרך, על ההדרכה, על ההשראה, וכן גם על זה שבזכותך כל פעם שאני נתקלת ברכיב מסתורי במעבדה, אני עוצרת ותוהה, אולי בכל זאת אפשר למצוא לו חיים חדשים? אז נעבור למחקר שבחרתי להציג היום.
יש מישהו ששכח את התיק שלו למטה? התיק הזה הולך לביטחון עוד רגע. מי שכח?
אוקיי, נעבור למחקר שבחרתי להציג היום. המחקר עוסק ברצף הייצור והצריכה של חומרי בנייה מחרס בירושלים הרומית. הכוונה היא לחומרי בנייה כמו רעפים, לבנים וצינורות, החל מהמאה הראשונה ועד המאה השלישית לספירה. חומרי הבנייה מחרס או ה-Ceramic Building Materials קרויים במחקר בקיצור CBM. ומדוע הניתוח של ה-CBM בירושלים וסביבתה בכלל מעניין? אני אראה איך הוא מייצג זיקה בין ייצור צבאי לאזרחי, ומעניק מבט חדש על המרקם החברתי דמוגרפי של ירושלים וסביבתה. בחפירות בשנות ה-50 של המאה הקודמת ובשנות ה-90 וגם ה-2000 באזור הכללי של רכס גבעת רם, אזור התחנה המרכזית בנייני האומה, נחשף אזור תעשייה רחב ממדים שהתמקד בייצור כלי חרס. שימו לב במפה, ניתן לראות את תפרוסת הכבשנים באזור. רואים כאן רק חלק מהכבשנים שנחפרו במהלך השנים. ראשית הייצור של הכלים במקום החל בימי החשמונאים, אז ייצרו באתר בעיקר קנקנים, קנים וסירי בישול, והצבע הסגול מייצג כבשן חשמונאי מהחפירות של רון בארי ודנית לוי בקראון פלאזה. בצהוב מסומנים כבשנים מהתקופה הרומית הקדומה, ההרודיאנית, כאשר בימי הורדוס הפך המקום לאתר ייעודי לייצור סירי בישול. בירוק כבשן אחד בודד שהיה בשימוש בתקופה הרומית הקדומה, אך שופץ לאחר 70 בימי הליגיון הרומי, תזכרו אותו להמשך ככבשן שכבה 5 בקראון פלאזה. וריכוז הנקודות האדומות אלו הכבשנים שהוקמו והופעלו על ידי הליגיון הרומי, והם נחפרו על ידי בני ארובס וחיים גולדפוס. במחקר על בתי היוצר באזור שפרסמנו לפני 5 שנים בבייסור, זיהינו מפנה לאחר שנת 70 לספירה עם הגעתו של הליגיון. אחד, הייצור של חומרי הבנייה מחרס התרחב משמעותית. לפני שנת 70 השימוש ב-CBM בירושלים וסביבתה היה מצומצם מאוד. ושתיים, לאחר 70 החל לראשונה ייצור של רעפים, שהיווה חידוש לרפרטואר ה-CBM המקומי, שכלל עד אז בעיקר אלמנטים לבתי מרחץ כמו צינורות, טובולי ולבנים. המחקר מצביע על כך שלאחר החורבן חלו שינויים משמעותיים גם בחומרי הגלם ששימשו לייצור בבתי היוצר, ולמעשה הליגיון החל להשתמש במתכון מיוחד של חומרי גלם, בעיקר לייצור של ה-CBM. אז המתכון של הליגיונרים הוא כבר לא סוד צבאי, כנראה גם לא היה, לכן אני מרשה לעצמי להציג אותו כאן. אבל לפני החשיפה, פרסומת אחת וחזרנו, אז כמה מילים על תצורת מוצא, מאחר והתצורה הזאת היוותה את המקור העיקרי של חרסיות לייצור קרמיקה בירושלים וסביבתה לאורך כל ההיסטוריה. במהלך השנים מקובל היה במחקר הפטרוגרפי של קרמיקה לייחס לתצורת מוצא שני פרטים, אחד חברי ושני חרסיתי, ויש להם הופעה מאוד ברורה בשקפים. התצורה חשופה באופן כללי מחברון בדרום ועד שכם בצפון, ובמפה שלפניכם ניתן לראות בצבע הכתמתם את מחשופי התצורה באזורים הרלוונטיים למחקר שלנו, במורדות המערביים של קמר רמאללה, קמר יהודה. אולם הסתכלות מעמיקה במספר חתכים של תצורת מוצא, לדוגמה החתך של בן תור ליד הבית האדום במוצא, החתך של ארקין וחובריו בדרך בין עין כרם לצובה, ומחשוף יפה באזור הקסטל שנחשף במהלך העבודות על כביש 1 והצטרפתי ליובל לדגום ממנו חרסיות בשנות ה-90. כל החתכים הללו מראים תמונה מורכבת יותר של יחידות חרסיתיות, חבריות, יחידות גירניות ויחידות עשירות במאובנים, וניתן לראות שבכל אחד מהחתכים מסומן כאן בצהוב יש יותר משתי יחידות עשירות בחרסית פוטנציאליות לייצור קרמיקה. אז הנה הגענו למתכון של הליגיון. חומר הגלם של הליגיון מאופיין 1 בטין קרבונטי, 2 כמויות משתנות של גבישי דולומית רומבואדרליים, 3 נוכחות משמעותית של שברי מאובנים, ו4 גרגירי קוורץ גסי גרגר מעוגלים. רומבים של דולומית אופייניים ליחידות שונות במוצא וגם לתצורת המנדב המונחת מעל המוצא. הקוורץ מקורו בחוף, קביעה מבוססת על צורת הופעתו ומינרלים נלווים שנצפו בשקפים. כאן ניתן לראות שקפים נוספים שממחישים את הנוכחות המשמעותית של שברי המאובנים ב-CBM של הליגיונרים. שברי מאובנים כולל מולוסקות ואוסטרקודות, אופייניים ליחידות מסוימות במוצא, ודוגמאות של אוסטרקודות שנלקחו מהחתך בקסטל וגם מאזור בית ג'אלה הקרמזן, זוהו כמאובנים מנחים לתצורת מוצא. לצערי החתכים השונים של המאובנים בשקפים שלנו לא מאפשרים לזהות מינים ספציפיים, כך שנסתפק בהגדרה הכללית שיש לנו בשקפים עושר של שברי מאובנים של אוסטרקודות או מולוסקות, ושאלו אופייניים ליחידות מסוימות בתצורת מוצא, ויש לציין שמאובנים אופייניים גם לתצורת המנדב המונחת כאמור על גבי תצורת מוצא. כעת אחרי שהבנו מה מקור המרכיבים השונים במתכון הליגיונרי, נחזור לבתי היוצר. הכבשן שבתמונה שייך לשכבה 5 בחפירות קראון פלאזה. הכבשן היה בשימוש לפני 70, אבל לדעת החופרים שופץ לאחר החורבן ביוזמת הליגיון והופעל בידי קדרים יהודים. ייצרו בו חומרי בנייה במתכון הליגיונרי, אך ללא תוויות ליגיון. כפי הנראה היה זה בראשית המאה השנייה לספירה, כאשר הליגיון ייסד בית יוצר חדש, מסומן בנקודות האדומות כאן בתוכנית. בית יוצר זה עקב אחר המתווה הצבאי הטיפוסי של כבשנים במחנות ליגיון ברחבי אירופה, עם עקרונות ארגוניים דומים. גם בבית יוצר זה כמובן היה שימוש במתכון הליגיונרי, ולהבדיל מהכבשן של קראון פלאזה שכבה 5, חומרי הבנייה כאן הוטבעו בתוויות ליגיון. דרך אגב, בדקתי קשת מגוונת של סוגי תביעות, גם את העגולות עם סמלי הליגיון שברג ייחס בעבר לשלב קדום של פעילות הליגיון, וגם את התביעות עם הכינוי או הכותרת אנטוניניאנה שמייחסת אותם לשלהי הפעילות של הליגיון בבית היוצר, וכולם עשויים מאותו מתכון. בדיקות פטרוגרפיות של עשרות חומרי בנייה עם תביעות של הליגיון העשירי מחפירות נוספות בירושלים וסביבתה, כמו קשת ווילסון, רמת רחל, הר ציון ואתרים נוספים, מצביעות על כך שהליגיונרים השתמשו במתכון הזה באופן עקבי. השימוש העקבי במתכון על ידי הליגיון אפשר לי לייחס לליגיון חומרי בנייה שלא נמצאו עליהם תביעות. היכולת לקבוע על פי המתכון איזה חומרי בנייה הם ייצור של הליגיונרים ואיזה לא יוצרו על ידם, הניבה שורה של מחקרים על חומרי בנייה בירושלים וסביבתה עם שותפים רבים, ואציג את חלקם כאן בקצרה. בחפירות של הארוני ברמת רחל נמצאו עריכי רצפה מחרס בבית מרחץ של וילה רוסטיקה משלהי המאה השנייה ראשית המאה השלישית, ועל העריכים כתובת קצרה בלטינית הנושאת 3 אותיות IVL. בחפירות הרחוב המדורג בעיר דוד נמצאו צינורות ולבנים עם טביעות זהות של IVL, ודוגמה בודדת נוספת נמצאה בחפירות בנייני האומה לא בקונטקסט. ההרכב של כל דוגמאות ה-IVL שנדגמו לפטרוגרפיה, כפי שניתן להתרשם מצילומי השקפים לפניכם, כולל רומבים של דולומית ושברי מאובנים, בדומה להרכב של מתכון הליגיון, אך מרכיב בולט בנוכחותו בחומרי הבנייה של הליגיון נעדר מחומרי הבנייה עם הטביעות IVL, אלו הם גרגירי הקוורץ. מאחר והקוורץ מופיע באופן קונסיסטנטי בכל חומרי הבנייה של הליגיון, הסקנו שטביעות ה-IVL לא יוצרו על ידי הליגיון. הכתובת IVL היא כנראה קיצור הקוגנומן יוליוס. יוליוס היה שם נפוץ, ומספר עדויות מצביעות על הקשר של יוליוס לליגיון, ואולי על כך שהיה וטרן שלמד את רזי המקצוע בימי פעילותו כקדר של הליגיון. א', צורת התביעה בתוך מסגרת מרובעת בדומה לחותמות של הליגיון. ב', השימוש בהרכב דומה מבחינת חומר הגלם. יש לשער שכיצרן פרטי לא עשה מאמץ להביא את הקוורץ מרחוק. ג', צינורות בעלי פרופיל דומה יוצרו על ידי הליגיון עצמו. ניתן להציע כאפשרות שיוליוס חכר או קנה את בית היוצר של הליגיון. תופעה דומה ידועה מבתי יוצר אחרים של ליגיונות רומים, כמו לדוגמה זה של הליגיון ה-20 בהולט באנגליה. מחקר נוסף נעשה בשיתוף פעולה עם מספר חוקרים על חומרי בנייה מחפירות קשת ווילסון, מקונטקסט המתוארך לאמצע המאה השלישית. יש לציין שקריאה של טביעות על CBM מציבה קושי מאחר והטקסטים מנוסחים במשורה וכוללים יותר קיצורים מן הנהוג בדרך כלל באופן כללי בכתובות. בחפירה נמצאו קרוב ל-40 חומרי בנייה מחרס עם קיצורים של השם המלא קולוניה איליה קפיטולינה. הקיצורים מופיעים בכמה ורסיות, ורק הסתכלות על כל מכלול הכתובות אפשרה את הפענוח שלהן. לעתים שרד רק חלק מהקיצור, לדוגמה כאן למעלה מופיעים שברים ששרדה בהם אות 1 או 2, ולמטה ורסיה מלאה יותר. המחקר הפטרוגרפי הצביע על כך שלייצור המוניציפלי של חומרי בנייה מחרס של העיר איליה קפיטולינה נעשה שימוש בשתי היחידות המוכרות של תצורת מוצא, חבר מוצא וחרסית מוצא, ולא במתכון הליגיונרי. לאחרונה הרחבנו את המחקר ובדקתי חומרי בנייה משני אתרים נוספים המייצגים את פרק הזמן של אחרי שנת 70. אחד שועפאט, יישוב יהודי, ומנגד חומרי בנייה ממוצא הווטרנית. ניתן לראות כאן סיכום של התוצאות שיוצגו בקרוב במאמר משותף ב-IJ, והן משקפות את כל רצף הייצור. הצבע הוורוד מייצג את המתכון הליגיונרי. בצד שמאל למעלה ניתן לראות אותו בשלושה מכלולים. הם מוקפים בריבוע והם מייצגים את פרק הזמן של בין המרידות. למעלה זו שכבה 5 בקראון פלאזה, במרכז שועפאט ומתחת מכלול משכבה 9 במוצא. בקראון פלאזה ובשועפאט ה-CBM מופיעים ללא טביעות. במוצא התגלתה תופעה ייחודית של טובולי עם טביעות של שם פרטי. זו התביעה הפרטית הקדומה ביותר המוכרת לנו באזור, והיא שייכת לקטגוריה ייחודית שלא ארחיב עליה כאן. בשועפאט כל הרעפים יוצרו מהמתכון הליגיונרי, אך לבנים, צינורות וטובולים מהאתר יוצרו בעיקר מחומרי גלם מקומיים אחרים. אלו מסומנים בתרשים בצהוב וירוק, ולדעתנו משקפים בתי יוצר נוספים שפעלו במקביל לזה של הליגיון, כפי הנראה של אותם קדרים שייצרו CBM לבתי מרחץ גם לפני החורבן. ניתוח חומרי הבנייה משועפאט, מוצא וקראון פלאזה מספק תובנות חדשות על יחסי הצבא הרומי והאוכלוסייה היהודית בירושלים, פוסט החורבן וטרם הקמת איליה קפיטולינה. יחסים אלו באים לידי ביטוי דרך חומרי הבנייה בשני אופנים, ומעידים לדעתי על מדיניות רומית לשילוב האוכלוסייה היהודית במערכת המיסוי. בשועפאט השימוש ברעפים שיוצרו בידי ליגיונרים מעיד על מעורבות רומית ישירה בהקמת היישוב היהודי, שהוקם לצורך מתן שירותי דרך וכמרכז לגביית מיסים. ובקראון פלאזה שילוב קדרים יהודים בתעשיית הליגיון מצביע על השתלבותם במערך הייצור הרומי. בעולם הרומי עבודות נוספות נחשבו כחובות מס כמו סלילת כבישים והובלת סחורות. נעבור לבית היוצר של הליגיונרים, בנייני האומה, רשום כאן כ-JICC. בניגוד למכלולים שהראיתי המתוארכים לתקופה של בין המרידות ובהם לא נמצאו על ה-CBM תביעות ליגיון, בבית יוצר זה מופיעות תביעות ליגיון, והשימוש במתכון בבית היוצר הזה נמשך עד לסוף המאה השנייה, ראשית שלישית, עד לסיום הפעילות שלו. התרשים ממחיש שינוי משמעותי במאה השלישית. מתחילה מגמה של ייצור אזרחי עצמאי, בדומה לפעילותו של יוליוס שכבר הכרנו כאן, ובמקביל מתפתח הייצור האזרחי המוניציפלי של קולוניה איליה קפיטולינה. הייצור האזרחי היה מצומצם יותר בהיקפו, והתבסס על חומרי גלם שונים מאלה של הליגיון. ייתכן והייצור הצבאי פעל בשלב האחרון שלו במקביל לייצור האזרחי. אם בעבר העיסוק בחומרי בנייה משך את החוקרים בעיקר בזכות תביעות החותם שעליהם, שכללו שמות של קדרים, של בעלי בתי מלאכה, של סנטורים, קיסרים וכמובן ליגיונות רומים, הרי שבשנים האחרונות גוברת ההתעניינות גם בחומרי בנייה נטולי תביעות. יש לציין שרק אחוז מסוים מחומרי הבנייה הוטבע בתביעה. לדוגמה, במחקר שנעשה בשנים האחרונות על כ-25,000 CBM מחפירות הצלה שונות לאורך קו הרכבת רומא-נפולי, נמצא שבמאות הראשונה עד השלישית רק על 4.5% מה-CBM היו תביעות. אם כי יש לציין שבימי אדריאנוס אחוז התביעות היה גדול בהרבה. גם כאן באזורנו מתחיל לפרוח העיסוק בחומרי בנייה מחרס נטולי תביעות, כמו המחקר שלנו על חומרי הבנייה משועפאט, ומחקר משותף שלי עם איתמר טקסל שפורסם לאחרונה, שעוסק בחומרי בנייה ללא תביעות מחווה רומית ליד אשקלון, שהוקמה במאה הראשונה לספירה. המחקר מצביע על סחר ימי ב-CBM, מאזור ביירות ומקיליקיה לאשקלון, וכנראה מהווה רק את קצה הקרחון להיקף התופעה של הסחר הימי ב-CBM במזרח הים התיכון, וכל זה לצד הייצור המקומי שדיברתי עליו היום.
Thank you very much. Our next speaker will be Shai Bar and Yotam Sher. Shai Bar is a researcher in the Ziban Institute of Archaeology at the University of Haifa. He directs the Menashe Hill Country Survey, the excavations of Tel Assur, and the Fatzael Valley Prehistoric Project. Dr. Yotam Sher is a senior lecturer at the Department of Cultural Heritage at the School of Archaeology and Maritime Culture in the University of Haifa and head of the Analytical Laboratory of the Israel Antiquities Authority. They will be presented on the topic Chalcolithic Fazael, before and after Yuval, the Metallurgical Revolution.
צהריים טובים לכולם. קודם כל השם בעברית, השם באנגלית לא משקף. עוד שנייה אנחנו... מטה, תודה. מן הגורן ומן היקר. פצאל החלקוליתית לפני יובל והמהפכה המטלורגית עם הצטרפותו. שני שבועיים סיימנו את העונה 19 בפצאל, הזדקנו עם האתר, וכשאתה חופר כל כך הרבה שנים באותו אתר זה כבר מתחיל לפעמים לשעמם, ואני מאושר שלפני 5 שנים יובל עם צוות מטלורגים נוספים, אבל בהובלה וביוזמה של יובל, הצטרף לחפירה בפצאל ושינה כל מה שאנחנו יודעים בערך על האתר, ותרם רבות רבות רבות, ואני מודה לו על כך. אני שמח מאוד להרצות על פצאל, אבל באמת עוד פעם, ההרצאה היא אומנם על פצאל, אבל היא הרבה יותר גם על יובל. פה אנחנו תפילת הבוקר במקדש גמל הנחושת בפצאל, שאנחנו מתפללים ומודים לאל שיובל יצטרף אלינו. כמובן שהפרטים הארכיאולוגיים, אם אתם רוצים, זה חלק כבר פורסם וחלק לא, אני מדבר על דברים אחרים באמת, אבל יובל תרם רבות לחפירה בתחום המטלורגיה, אבל אני חושב שמטלורגיה זה לא הכל בחיים, בטח שאתה עושה פרויקט כל כך ארוך, כל כך מגוון, כל כך מעניין. אז התרומה העיקרית של יובל, שאני באמת חושב שהקפיצה את החפירה ברמות שבאמת קשה להקביל אותן, זה. כי אנחנו מתגאים בקולינריה שלנו, אבל ההצטרפות של יובל גם בתחום הקולינרי וגם בתחום היקב, בתחום השתייה, שדרגה מאוד את החפירה. פה עוד כל מיני דוגמאות במהלך העונות, אז ככה שמי שלא זכה לטעום, אנחנו ממש ממליצים בעונה הבאה, תהיה עונה 20, ולבוא לאכול איתנו בחפירה. עוד דבר שקרה זה שאנחנו התחלנו ללמוד כל מיני מילים חדשות, רק כדוגמה אחד, למשל, אני לתומי בתור חובב גשש, מי שזוכר את הגששים, יודע שבלוקים זה מה שנגמר, שזורקים אחרי שנגמר החצץ נגד פתח תקווה, מי שמכיר את הגשש, אבל התחלנו ללמוד כל מיני מושגים כמו בלוקים ומושגים אחרים, ובאמת למדנו המון, כל הצוות, ויובל, מי שמכיר אותו טוב, יודע שהוא אוהב ללמד גם, אז זה בהחלט חוויה מרגשת. עוד דבר שמשותף באופן אקראי לגמרי לי וליובל זה ששנינו תותחנים, שנינו קציני תותחנים, יובל קשה, אני יותר קצין ארטילריה, אני יורה לאן שהוא מבקש, אבל בהתאם להגדרה פעם תותחן תמיד טייס, או פעם טייס תמיד תותחן, אז במקרה אנחנו הפכנו אותה, ויובל הפגין ורחפנות גדולה מאוד באתר, ובאמת חברו הטוב ביותר של יובל בחפירה זה הרחפן, או הרחפנים, כי היו כמה, ויש לנו צילומים נהדרים מכל העונות, וגם על כך אנחנו מודים לו רבות. ורק נגיד, נציין עוד את האהבה שלו לגילוי מתכות בכלל, ואת הנטייה שלו לעמוד ככה מעל החופרים בשקט ולהסתכל עליהם, כשהם קצת חוששים למטה ולא יודעים, ואחר כך לבוא ולהגיד להם בצד מה הוא חושב. הוא אדם מאוד גם מנומס וחביב. אז זה ככה יובל וחפירות פצאל, לא בפן המטלורגי, כי הפן המטלורגי כבר התחיל לעשות רעש ויעשה עוד הרבה רעש, אני מקווה בעתיד הקרוב, וגם יותם ידבר על זה אחריי. אני רק רוצה ככה לתקצר מה זה בעצם הפרויקט הפרוטו-היסטורי בבקעת פצאל. מזה 19 שנים, מסיום הדוקטורט, אגב, עוד הערת אזהרה, בעצם יובל זה אחד משני הבודקים של הדוקטורט שלי, אז בעצם זה באשמתו. אני חופר סדרה של אתרים בבקעת פצאל, בבקעת הירדן, אתרים מהחלקולית והברונזה קדומה 1, אתם יכולים לראות אתרים שהתגלו בסקר המנשה, ואתם יכולים לראות את המפה, את התצ"א, ולראות את אתרי הברונזה קדומה 1, פצאל 4 ושייח' דיאב 2 במערב העמק, קרוב לנקרת הצרה, ואת האתרים החלקוליתיים, זה כל קבוצת האתרים שממזרח עד היישוב עצמו, שיש לנו את פצאל 1 שהוא הקדום ברצף החלקוליטי, שהוא למעשה חלקולית רסולי, אולי יש בשלב קדום, ו2, 5, 7 ופורת הם חלק מיישוב אחד גדול ששטחו קרוב ל-200 דונם מהתקופה החלקוליטית. פצאל 1, 3 שכבות, שהתחתונה אולי הוא אפילו מה שנקרא חלקולית תיכון, אולי חפרנו שטח מאוד מצומצם וצריך להרחיב בשביל לדעת, אבל ממצא חומרי לסוגיו שמאפיין את החלקולית הרסולי המאוחר, ואתם יכולים גם לראות ארכיטקטורה רגילה של בתים עם חדרי רוחב, חצרות, בגודל, בקנה מידה שמאפיין את האתרים האחרים, כמו תולילת רסול שלא כל כך רחוקה, ואבו חמיד ואחרים. אבל כשאנחנו עוברים לאתרים של החלקולית המאוד מאוחר, אז יש לנו את פצאל 5, שרק דגמנו אותו, הוא הגדול מכולם, 2 בתי חצר גב אל גב, חפרנו חדר אחד בבית החצר המערבי, וכבר בבית החצר הזה מצאנו את שני האלמנטים, לא בדיוק סטריגרפיים, האלמנטים התרבותיים המקשרים את אתרי פצאל השונים אחד לשני. אחד זה פסולות נחושת למחזור, הדבר השני זה להבים כנענים, אז יש לנו את זה בכל אחד מהאתרים. אז פצאל 5 זה אחד מהם. חפרנו בפצאל 7, פצאל 7 צמוד לגדר, אתם רואים, של היישוב עצמו פצאל, גם כן כמעט 3 דונם, יחידה אחת גדולה מאוד של בית חצר ועוד 2 חצרות סמוכות, ובתוכה היחידה המקורה, מבנה המקורה הגדול ביותר שנחפר היום בלבנט מהחלקולית. יש לנו פה 120 מטר רבוע מקורה, זה לא רע, בירושלים, בתל אביב 120 מקורה זה נכס לא רע, עם חצר כזאת לפעמים. אז פה יש לנו את זה כבר בתקופה החלקוליתית עם השתמרות של קירות לגובה של עד 1.5 מטר, שזה גם מאוד חריג בתקופה הזאת. אני מקווה מאוד שהאתר הזה ילך לשימור כי הוא מאוד מיוחד. ובתרבות החומרית שלו, כמו שאמרנו, גם להבין, במכלול הצור, גם להבין כנעניים, מה שמחבר אותו לתרבות של פצאל בסוף החלקולית הרסולית, וגם פריטי נחושת, גם שלמים, גדולים, יפים שהיה בהם שימוש, וגם פריטים למחזור רבים, ועוד כל מיני ממצאים שרלוונטיים. ופצאל 2, הנה תמונה שיובל צילם בעונה שעברה. יש לנו פה בית חצר גדול, גם כן דומה לפצאל 7, 2.5 דונם בערך, שכולל חצר רבועה, כמעט רבועה, 20 על 25 מטרים, ואליה ניגשים 3 חדרים. תאריכים רדיומטריים שנלקחו בעונה הראשונה מראים שאנחנו בראשית, במאה הראשונה של האלף הרביעי לפני הספירה, ולשמחתי הרבה תאריך נוסף שבוצע ממש לפני שבוע וחצי, יובל סיפר לי עליו, מטעמי תעשיית המטלורגית שיש לנו פה באתר, הביא תוצאה דומה, גם כן 3,900, ולכן אימץ סוף סוף את התאריכים הראשוניים שנלקחו בעבר. כשבאתר הזה 3 שכבות, שכבה מאוחרת הלניסטית, לא כל כך רלוונטית לענייננו, שכבה קדומה על הקונגלומרט, סדרה של בורות, אתם רואים את 3 החצים מצד שמאל, אז בצד השמאלי יש לנו, רואים את הבור מתחת לבית רוחב חלקוליטי, גם השכבה הזאת עם התקופה החלקוליטית, אבל אנחנו יודעים עליה יחסית מעט כי נחשפה במעט מאוד מקומות באתר, והשכבה העיקרית היא אותו בית חצר גדול ובו סדרה גדולה של מתקנים. על פצאל 2 אפשר לדבר הרבה, זה דוגמאות למתקנים שנחקרו או נחקרו רק בעונה האחרונה. יש לנו למעלה מ-40 מתקנים מעוגלים מסוגים שונים באתר. מה התגלה באחד מהם יותם עוד מעט יספר לכם. ממצא קרמי חלקוליטי, מבחינתי אמנם אין מחבצות ויש בזיך בודד, אבל יש לנו המון, יש לנו למעלה מ-150 קערות ישרות דופן עם ליפסטיק. עדיין אנחנו בתחומי התרבות הרסולית של התקופה החלקוליטית. במבצע הצור, עוד פעם, כבר דשנו בזה מספיק, אבל אחרי העונה הזאת יש לנו כבר כ-110 להבים כנענים. אני חושב שזה כבר מראה שהם הגיעו לאזור כבר בתקופה החלקוליתית, בשלהי התקופה החלקוליתית, יחד עם כלים טיפוסיים לתקופה החלקוליתית עצמה, ורק לאחרונה פורסם מאמר השנה בספר לכבוד סטיב רוזן על הלהבים הקטנים מפצאל. נחושת ממש אני אשאיר ליותם, אני רק אזכיר כמובן את השורה התחתונה, Identification of פצאל 2 as a first lost wax casting workshop in the Chalcolithic Southern Levant, וזה בעצם המהפכה הגדולה מבחינתנו באתר. כן, יש לנו קבורות, אני לא רק רץ עליהם מהר, יש לנו קבורות תינוקות בקנקנים מתחת לרצפות. אחת מהם חקרנו באמצע כבר אז לפני כמעט 20 שנה, כשהמציאו איזה מכשיר שנקרא CT, ועשינו ניסוי עם המכשיר הזה באישון לילה. אתם רואים פה תינוק בן חצי שנה שוכב בתוך קנקן קבורה, ואחד הדברים היפים זה שה-CT אפשר לראות שבעצם יש פקק חומר שפוקק שהתינוק יושב עליו, וכשחפרנו את הקנקן הזה לא מצאנו את הפקק חומר. ועוד פעם היתרון, משהו נוסף מדעי שמאפשר לנו ללמוד. אם היינו חופרים בלי לעשות את ה-CT, אז כנראה שלא היינו יודעים שהיה בכלל פקק חומר שעליו מונח התינוק. כמו שאמרתי, יש קבורות נוספות, פורסמו, ויש לנו עוד תופינים מהאתר בשלבי מחקר כאלה ואחרים, שאפשר לראות פה דוגמאות שלהם. והשאלה היא למה מגיע לי כל הטוב הזה, לא לי באופן אישית, אלא למה האתר הזה כל כך עשיר ומיוחד וגדול, ואת התשובה יותם מוזמן לתת בפן המטלורגי. התשובה היא, סיבה היא מטלורגי.
אוקיי, אז רגע, אני אנסה פה איזה תרגיל כזה, או לסגור מצגת זה תמיד הורג את כולם. אני פה רק רוצה להגיד שתי מילים, כי אני סוגר פה מעגל עם יובל של איזה מעל איזה 10 שנים. יובל ואני התחלנו במאסטר, שבעצם הוא היה מדריך שלי במאסטר, חנך אותי, והיום אנחנו חונכים ביחד סטודנטים, אז בכלל סגירת מעגל מאוד גדולה, ובמהלך 10 שנים האלו, אני ויובל לימדנו כמה קורסים ביחד, כל אחד בתחומו, במיקרו-ארכיאולוגיה. וב10 שנים מיקרו-ארכיאולוגים לומדים ביחד, אז מדברים, וכמובן זה לא סוד, יובל מחפש את סוד השאהבה העבודה, ובמיקרו-ארכיאולוגיה אחד הדברים שהתעסקנו בהם לא מעט זה איך מוצאים שרידים לתעשייה שהיא בעצם נעלמת מהרקורד הארכיאולוגי. אז כמו ששי אמר, ברגע שהתחילו להתגלה ממצאים בפצאל שמעידים על סגסוגות, נפל לנו האסימון שאנחנו בעצם צריכים ללוות אתר מההתחלה ועד הסוף עם הכלים הארכיאולוגיים שלנו ביחד עם כלים מיקרו-ארכיאולוגיים, וכמו שאתם יודעים, יובל יש לו מעבדה ניידת, אני גם חובב מעבדות ניידות, שנינו הצטרפנו לזה ביחד עם סריאל, ואני חושב שנעמה הראתה את התמונה הזו קודם, שבעצם הובלנו איזה מחקר מאוד יפה על השאהבה העבודה ועל הניסיון שלנו למצוא אותה בפצאל. אז אני הולך להחזיר את המצגת ולהראות קצת תוצאות, אבל בעיקרון הצלחנו לא רע למפות בפצאל את המיקרו-ארכיאולוגיה, את כל השרידים המיקרו-ארכיאולוגיים, בין אם זה סיגים ובין אם זה פוריות גם, ובין אם זה כל מיני דברים קטנים שנעלמים מהארכיאולוגים, לא רק הצבועים בעין בירוק וממש מדברים וצועקים לעין מתכת מתכת, אלא גם דברים שהם לא. זאת אומרת, כל מיני נודולות של בעצם אדמה שרופה או משהו כזה, שכל ארכיאולוג היה פשוט פותר אותה או שופך אותה ימינה, ואנחנו מצאנו המון עניין בה, כי בעצם כשעושים שאהבה עבודה ושופכים את המתכת לתוך התבנית, התבנית לא באמת מקבלת טמפרטורה לאורך הרבה זמן בתנאים שהיא יכולה להצטרב, אלא היא מקבלת שוק טרמי מאוד מאוד חלש נקרא לזה, והיא מתפוררת. זאת אומרת, היא לא באמת סובלת את מבחן הזמן. אז כשאנחנו ממפים את השרידים המטלורגיים, ואנחנו קוראים לזה שרידים מטלורגיים כי זה חלק מהשאהבה העבודה, בפצאל אנחנו רואים פה חצר של פצאל 2 מאוד יפה, עם אזורי פעילות סביב המתקנים האלו ששי הראה. יובל כמובן לימד את שי את כל הטכניקות האלו, ובעצם הקפיץ למעלה את השיטות עבודה באתר, והראה לנו בעצם איך כמובן מנהלים מעבדה ניידת, ואני אקפוץ הלאה לממצאים, כי בעצם מעבר לזה שהכימיה בתוך החלקיקים האלו, שהם צבעוניים והם מכילים מתכת והם דבוקים לנודולות האדמה האלו, הראו לנו באמת שבמתקן ספציפי אחד שהוא היה חתום מאוד יפה, ראינו קורית וראינו את כל הפרילס וראינו את כל הדברים האלו שהם מכילים מתכת, נחושת עם סגסוגת של ארסן וקצת אנטימון, ופה למטה, הכי למטה בעצם רואים איזה סוג של אדמה כזו שרופה, שאם אתה נוגע בה היא קצת מתפוררת, לגמרי מתפוררת, והיא בעצם חלק מהעולם הזה, העשיר הזה של תבניות, שמקבלים את השוק הטרמי. קצת תמונות על הכימיה שבאמת מראים שיש גם כסף, שזה חלק מהמכלול הזה של המתכות שמגיעות מהבצר הזה שהגיע מחוץ לארץ בצורה כנראה של מתכות. פה אנחנו רואים בעצם בפצאל איזה סיפור מאוד מעניין, כי אין לנו בצר ואין לנו עופרות, זה הכל סוג של מתכות שמכילות את הסגסוגת הזו, שאחת התיאוריות זה באמת שהכל היה במחזור, מחזרו שם את המתכות האלו במתקנים האלו, ועל בסיס התאריכים האלו זה לקראת ה-4000, וכמו שיובל הראה בפורום הכלכוליטי, מי שלא היה שם, אז התחלנו לעשות ריפיינמנט לכרונולוגיה בתקופה הכלכוליטית על ידי התיארוך של התבניות מנחל משמר, וזה חלק מהפרויקט הגדול שכולנו שותפים אליו. אז אני רק יראה קצת תמונות נוספות על הקורית הזו. אז באמת עם הקורית התחלנו לעשות פרויקט נוסף שמגדה הסטודנטית המשותפת מובילה אותו, וזה בעצם גם להסתכל דרך ספקטרוסקופיה ביחד, יובל עם המיקרוסקופיה, עם השקפים, כמו שראינו פטרוגרפיה, וגם ספקטרוסקופיה, להבין לעומק מה קורה לאדמה או לחרסיות שלא עוברות צריפה ולא מקבלות את הסיגנל של עיבוד המים, כיוון שהם לא עברו צריפה כמו שאנחנו רגילים עליה בקרמיקה, אלא רק מקבלים שוק טרמי שהמים המבניים עדיין שמה, ואיך מזהים את זה שזה נחשף לשוק טרמי. אז עבודה שלמה עשינו על זה, ופה רואים את הכורית הזו שבאמת מכילה גם את המתכות עם הסגסוגת וגם עברה צריפה כמו שצריך, כי זה כורית. המיקרומורפולוגיה בעצם מראה שהמתקן הזה עשיר בשכבה מאוד מאוד ברורה של חלקיקי נחושת עם הסגסוגות האלו, חתומים היטב, עם אפר, ובעצם היה שם פירוטכנולוגיה מאוד ברורה שאותה אנחנו מתארכים ל-4,000, ובגדול אנחנו יכולים לסכם את המהפכה הזו ששי דיבר עליה, על זה שיש אתר ארכיאולוגי שנחפר בצורה סטנדרטית במשך 15 שנה, ופתאום יובל ואני ושריאל מלווים כחלק מהפרויקט את החפירה הזו בעזרת מיקרו-ארכיאולוגיה, ומרימים את הכפפה ומצליחים לזהות, כמו ששי אמר, בעצם את הוורקשופ, את הסדנה הזו שעבדו בה בשיטת השעווה עבודה על בסיס חלקיקים קטנים שנעלמים מעין. אז תודה רבה, ופה אנחנו נסיים.
Okay, our next speaker will be Sharon Tagger. Sharon is head of the Conservation Department at the Israel Museum, Jerusalem. Sharon has practiced as conservator in the United Kingdom and in Israel, working on both national and private collections. She will be presenting on the topic From Prehistoric Figurine to Barbie Doll, collaborations between the Conservation Department of the Israel Museum and Professor Yuval Goren in the field of material research.
Hi, שומעים אותי? כן? Okay. I was asked to speak in English, so I will. So this is a great honor to be asked to speak on behalf of Yuval's work. So thank you, the organizers. I will be presenting the conservator side of working with Yuval, which might be slightly different from what we heard so far. And I hope you enjoy. So the Israel Museum represents a wide encyclopedic collection. It has over 500,000 collection items, and they vary from prehistoric to contemporary art. You can see on the slide here a representation of the human figure, on the left a prehistoric figurine, and then busts of chocolate and soap. Created in the 1990s by Janine Anthony. You can see the Dead Sea Scrolls, and you can see an object from the Fluxus collective, artists from the 1960s using ephemeral objects to represent the ideas of the time. So conservators in an environment like the Israel Museum really need to deal with a lot of questions about material culture. Sadly, we don't have an in-house conservation scientist, so we won't have to work in the dark, so to speak. We were very happy to collaborate with Yuval. I'll mention that Yuval has been working with the Israel Museum for, I think, 30 years at least. But the strong links between the conservation department and Yuval really tightened in the last, I think, decade. And many of the collaborations have stemmed from questions asked by conservators. So in conversations that I had with Yuval a few years ago, we both agreed that we needed the three-legged stool principle, which means that on the one hand, we've got the curator, the researcher, the archaeologist, whatever, and then we have the conservator who needs to work on the object, needs to prepare it for exhibition, needs to make sure it's stored properly in the storage space. And then we need a conservation scientist. Enter Yuval Goren. And we discussed common questions and a win-win situation where Yuval is leading his students from the faculty in Ben-Gurion University to practice on material research, really, and to deal with a lot of questions. And then on the other side, us conservators asking the questions to help us treat the collection better. The questions concern characterization of the material, technique, maybe dating, provenance, authenticity sometimes, degradation processes, identification. And then we really create a win-win situation for both parties. Most of the tests done were non-invasive. As Yuval always mentions, you have to start with a sort of milder, non-contact methods, and then, if needed, we progress to invasive analytical methods. So since 2018, and more formally since 2019, Yuval has brought groups of his students for field days, research days at the Israel Museum. We would prepare in advance a list of questions for him and his students, and then we would have conservators, curators, and Yuval and his team opening a mobile lab at the museum, sometimes in a dedicated room, sometimes in our labs, and answer questions to the best of everyone's ability. And I'm just going to mention here three very different projects done together, which I hope will demonstrate to all of you the great ability of Yuval to adapt to different periods, different questions, and come up with answers for us, and also be an educator at the same time, which I hope will also influence generations of material scientists to come. So I'll ease you in with something to do with archaeology before we venture into the fine arts world. So the first project that I'm going to mention today is the Neve Yam figurine. In preparation for the 2022 exhibition Adornments, Jewelry and Body Decoration at the Prehistoric Times, curated by Achiad Ovadia, curator of prehistoric culture, we decided to have another look at a pendant figurine. Found in 1969 by a local resident while the IAA and Haifa University were excavating in the Carmel Beach area, it was located in a few hundred meters from a late Neolithic site in Neve Yam. As the stone presents no stratigraphic links to the site and differs stylistically from other anthropomorphic figurines from that period, we asked Yuval and his students to help us with the identification of the stone and see if there are any material links to other periods or cultures in that context. Our brief for Yuval was to use non-contact analysis for the initial tests. And indeed, this is always a core principle in his teachings. Start with known contact and progress to samples if needed. XRF analysis was used for a point-and-shoot mineralogical identification. Green areas indicated silicate, magnesium, calcium, and iron, indicating to the presence of an epidote mineral. XRF is not sensitive enough to detect lighter elements, and Raman spectroscopy was chosen as the complementary non-contact analytical test. Spectral analysis promoted the identification of thermalite mineral, which, in combination with the identification of epidote, indicated that the mineral might have originated from areas that today are located in Cyprus and Turkey. As sail routes were already existent in the Neolithic era, it is possible that either the rock in its raw form or the pendant figurine arrived to the Levant. The flat back of the figurine, containing 3 drill holes, indicates its use as a pendant. However, no other object in this period either looks like this figurine or was used as pendants containing drill holes. Moreover, there are no past examples discovered that demonstrate the use of epidote or thermalite from the Levant. When compared stylistically to Mascala culture figurines from Mesoamerica, the Neve Yam pendant appears visually similar. In order to determine the origin and context, further research is needed. Examination of the pendant drill holes under SEM, and more accurate elemental analysis that requires sampling. So we eagerly anticipate continuation, Yuval. The next project I'm going to exhibit to you is examination of a Qajar painting. During 2023, the Conservation Department was busy with the preparation of objects from the exhibition The Rose and the Nightingale, curated by Lisa Lourier, due to open that summer, including treatment and conservation of paintings, decorative objects, jewelry, and costumes. You can see the image from the exhibition on your left. The exhibition focused on the art and decorative artifacts created in Iranian Qajar culture of the 18th and 19th centuries through depictions of idealized beauty, love, and royalty. While the style of the artifacts is completely Persian, the materials and techniques used by the artists and artisans trained in Italy, and particularly in Venice, are Western. One of the interesting examples examined with Yuval's students was a portrait of the great Shah Abbas. The painting on canvas was originally adhered to an arched-built niche in a palace. I don't know if you can notice the sort of arched scene here. At some unknown date, it was detached quite aggressively, lined on a new rectangular canvas, and stretched and framed in the style of Western paintings. Upon examination in the labs, the solubility parameters of the original painting differed from the top edition, and we needed to know what the chemical composition of the binding media is in both areas, as well as the pigment types used. An initial visual examination with Yuval students led to a decision to use portable XRF analysis to collect information about the elemental composition of the pigments. The students took 11 readings spread across the original part of the painting. Data was collected at 2 different points for each color in order to correlate the paint tones with the appropriate chemical composition. Using FTIR spectroscopy, it was possible to identify the organic binder in the original painting. A good accordance was found between the peaks in the analyzed samples and those that are characteristic of egg yolk. This is in accordance to the somewhat relatively limited existing literature on Qajar techniques, where it is noted that a shift from tempera to oil paints is dated to the last quarter of the 19th century. The collaboration between the curator Lisa Lourier, the conservator Goren, and the conservation scientists led by Professor Yuval Goren shed light into the history of this painting, the possible dating of its change in dimension, and also led to the decision to respect these changes and exhibit the painting as it is, without restoring it to the original dimension. The last example I will show you concerns plastic. Both the design and contemporary art departments at the Israel Museum contain hundreds of objects listed in the collection database as plastic, which in fact represents a very large and varied group of material. While the conservation of plastic objects has become an important concern, the preventive care and cleaning of these materials is still in need of further research. Due to the great variety of plastic formulations, each type of plastic contains its own scale of sensitivities to environmental conditions and preservation protocol. It is therefore crucial to identify it, particularly for the tailoring of successful surface cleaning treatments to reduce soiling. In general, soiling is a combination of different substances and particles, such as fatty acids and triglycerides from handling with no gloves, natural oils, dust, insect residues, fibers, etc. Other types of compounds found on the object surface include degraded adhesives and remains of previous restorations, sticky tape and labels from storage, or degradation products formed during the natural aging of the object. This affects the appearance, leading the viewer to focus attention on the obscuring soil rather than on the object itself. Plastic formulated with plasticizers and stabilizers presents particular cleaning challenges. For some of the deposits that accumulate on the surface and attract particulate soiling are also often integral components to the solid material. In general, plasticizers are additives that attach non-covalently to the polymer chains and confer plasticity to the material. Reducing the concentration of this additive makes the polymer harder and less resistant to impact, and may lead to stiffness and cracking. Wrong cleaning protocols also risk leaching additional and essential plasticizer or other additives from the bulk, which might compromise its physical properties, appearance, or stability, or encourage exudation of additional material to the surface. Residues left on the surface after cleaning may adversely affect the perception of the surface by loss of gloss and color modification. In addition, the chemical alteration of the surface due to the absorption of solvents may produce a swelling to the surface, as well as yellowing or darkening due to photochemical reactions. When the plasticizer has migrated from the bulk to the surface of the material, the surface becomes sticky, and that enhances the attachment of pollutants and dirt to the surface, causing conservation and aesthetic problems. By identifying the chemical composition of the object, and with the aid of Raman spectroscopy, we can tailor appropriate cleaning agents that will remove surface deposits, leave no residues, and will not penetrate below the surface. So one day we had Yuval examine some of the objects in our plastic collection, mainly Barbie dolls, to detect the type of plastic. In this case, it's PVC. In the case of PVC collection items, the best course of action is using dry mechanical cleaning. And if that is not successful, a small amount of water and non-polar solvent held in emulsion with a surfactant should yield satisfactory results. So in conclusion, by using Raman spectroscopy, we could have tailored a specific treatment for that object. And then we could also extrapolate on another object in our collection, Hans-Peter Feldman, which will be exhibited in the Israel Museum in about 2 weeks' time to the public. It's made of basically plastic toys that the artist collected throughout the years, and then you can sort of see the shadows of the rotating toys on the table when you enter the gallery. So in conclusion, I would like to acknowledge Yuval and Yotam Asher and Yuval's students, the curators of the Israel Museum, and the entire conservation team. And when I think of Yuval, I think about this quote, which I think really suits you, because obviously your work is your life, and you're passionate about it, and you're total about it, and it's felt when we work with you. And thank you so much. So thank you for your time.
Thank you, Sharon. Our next speaker will be Dr. Nomi Porat. She's a senior researcher at the Geological Survey of Israel, where she established the Laboratory for Luminescence Dating and has been conducting geoarchaeological research since her MSc in the mid-80s. Today, Dr. Porat will be discussing the Nakada 3A Canaanite pottery from Tom U.J. in Abydos.
I would also ask to speak in English. So, first, a disclaimer. I've not been doing any petrography of pottery for maybe 30 years, so maybe I'm not up to date. But what I will describe is the latest, the last project I did with Yuval, after a lot of collaboration in our early years. And afterwards, each one of us went his own way. So if I'm a bit, not updated, what's going on in the field, please bear with me. So, Nakad, I'll start with some history. I started my MSc on petrography of pottery with Zehut Amiran and finished in 1984. And Yuval was doing his master's a little bit later, but our PhD was roughly at the same time. And only at the end of my PhD, Zehut Amiran bothered to tell me that he's another guy doing petrography of pottery in Be'er Sheva. She used to keep things to herself. And then we were introduced and we started working together, and we were both very happy to be able to discuss joint ideas and promote the field we both worked on. So the whole idea between when we were talking together is to put order in the chaos of what we saw under the thin section. I was working on early bronze pottery from southern Israel, and the variety of composition was so big that at first it was a little bit overwhelming. Okay, you have this temper and this clay and this, and everything is combined. So we thought that if you want to make it into a science and you want to make it a little bit more quantitative and try to be able to compare between sites and talk in the same language and not just a little bit of this and a little bit of that, we should try and make it a little bit less descriptive and more, I don't know, maybe, I don't want to say numerical. So we also realized that we have the matrix or the clay and the temper, which are the inclusions, and these might not come from the same geological formation. As a geologist, I always try to see where the material came from. And we realized that by putting together the two locations of the temper and the clay, we might be able to pinpoint more closely the source, because we have a meeting place of two materials, which is easier to find than the spread of like the Mozart formation, which has a large, which I'm not talking about, which has a large range. So after like hundreds of thin sections between us and a lot of work, we realized there's only a limited number of clay types. And we started trying to describe them. I don't know if this concept is still useful, but we numbered them and we used them for a long time. And when I said clay number so-and-so, we both knew what we're talking about. So it was very useful. And we tried to characterize in great detail everything that we saw for reproducibility. So if Yuval describes a thin section and I describe a thin section, it should be more or less the same, which doesn't always happen. And then assign a geological or even a geographical source. And the temper, as we know, can be anything: crushed rock, wadi sand, beach sand, or any coarse material found, but the clay is more specific because it has particular requirements. So we came up with the concept of a kind of matrix, like a table plotting clay type against temper type, and that is one of the major tools that we used in the paper that I'm going to talk about in a minute. So this is an example of for my PhD, and here is a list of clay types, and this is their this is what they're made of. So we have clay which which is rich in carbonates and it's microfossils, and then for example clay number 4, which has dolomite, like what Anat showed, and etc. etc. And these are the numbers that we used for a long time. I don't know what happens now. And later on, we added number 0 because this is Nile clay. It has a lot of silt, and a lot of feldspars, and a lot of mica. So this was the basis for our classification of clays. And later on in my PhD, I also plotted the clay group against temper. This is from Arad, so the clay types were only limited, carbonate like this and carbonate like that. But you can see that different clay types have different kinds of temper. For example, quartz appears mostly in three crosses is a lot and one cross is a little, okay? So quartz appears mostly in these clay types, and for example, shale fragments and grog appear only in this clay type, and interestingly, they always appear together, and so on and so on. So it puts some sense and put some order into our observations. So what I'm describing is the last petrographic work that I ever did before. Well, I finished my PhD in 1989 and then went to do a postdoc on something completely different on geochronology of archaeological sites, ESR dating, and then luminescence dating. But after I returned in 1991, archaeologists used to come up to me and say, "Oh, could you please do some petrography of pottery that we found here and there?" And usually I couldn't, I said, "No, I'm sorry, I set up a lab and I had to improve my lab and work on other things." But when Yuval came to me with the idea of looking at this tomb UJ, I just couldn't say no. It was just such an exciting idea. And the number of samples was so huge that I thought you're going to come up with really good results. So that was the last last thin sections I looked at, well, not exactly, but the last big project that I did with Yuval on petrography, and we published it in 2002. So the work was carried out in the late 90s, more or less. And later on, two more papers were published on the same assembly that we worked on. I will mention them at the end. One from 2015, and one I regret to say I discovered only a few days ago when I was getting ready for doing some research for this talk from 2022, and all I read is the abstract, so I'm not very familiar with what they said in this paper. Okay, so let's talk about this project. It's in Abydos, or Abydos, some people call it. I'll call it Abydos, which is in southern Egypt, not far from the Nile. And if we look close, so this is the Google image. Here is the Nile River, and this is Abydos. And the tombs are in this bit of desert. Here you can already see the cliffs of the plateau, the limestone plateau that is mostly west of the Nile. And here is a map of the cemetery. It's a royal cemetery. It has tombs of kings and a lot of important people. And cemetery U, which we worked on, is this group, and tomb UJ is this little structure over here. So it's a huge area with tons and tons of fine and amazing stuff, and really well preserved. Really nice place. Okay, so this is what they found. This is the tomb, and they found hundreds and hundreds of intact, almost intact jars. Like this is one room, and this is another room, and this is like an example of one of the finds. And of course, everybody said, you know, Canaanite pottery, Canaanite pottery. And some of them do look like Canaanite pottery, but others, if you look at them with trained eyes, and by that time I was quite familiar with EB1, which is the equivalent, early Bronze 1, which is equivalent to this period, it wasn't quite, it was a little bit off, you know, like not quite exactly to what we see here in Israel. And here are some drawings from the paper by Hartung, and you can see different kinds of decoration. Some of them look similar, other look not so quite, but here are some of the types of vessels that were found in the tombs. Altogether, 700 jars were found in tomb UJ, which is unprecedented. So for this study, we got 130 thin sections, which is a huge number. And also, we really, really appreciate that archaeologists were willing to break small pieces of this fantastic treasure and give it to us and give it to Yuval to make thin sections. It's when I was doing my PhD like a decade earlier, I had to fight with every bit of Egyptian pottery, like Canaanite pottery found in Egypt, which was the issue of my thesis. I had to fight with archaeologists, you know, to get bits and pieces of it. So this was a very, very generous, I want to say gift, but very, very generous set of data. And in addition to the 133 sections, we looked also at 45 fresh breaks just under the microscope, not in thin section, just to make sure we didn't miss anything important. And then we used our combined experience, and you write it in the paper, and I couldn't believe that you wrote it. We've got more than 25 years of experience between the two of us, which is true. At the time, it was true. And the database by then already had 8,000 thin sections, most of them from Israel. So we had a really, really good cover of what is found in Israel and what temper is used and what clay is used, in what areas and what periods. And we used the concept of clay versus temper types and compared to early bronze pottery from Israel. And this is what we came up with. So on the top is the temper type, and here is the clay type, and it's the same numbers that I showed you before. So number 4 is it's the other way around. This is the clay and this is the temper. Clay number 4 is a dolomitic one, and so on and so on. Number 1 is calcareous. And each number is a sample. So you can see that there are tons and tons and tons of different combinations of clay and temper in this assemblage of jar. But to make things look easier, we put it in this diagram, which is, it actually has the same X and Y. So this is the clay types and the temper types. We just painted the squares. Dark squares like here have a lot of samples, white squares have none, and then you have like more depending on the shade of gray. So it gives you a good visualization of how many different groups we have here. Like about 20 different combinations of temper and clay. And even if we combine like calcareous with and its art form, we come down to 15 groups, which you don't expect from such an assemblage. You think, okay, it's a royal tomb with wine coming from one supplier, and all the jars are going to be the same, and they're going to come from one area. And it was really difficult to, how do we deal with such a variety, put some sense into it, and try to come up with where does it come from? Because obviously this comes from many different places. And one interesting thing is this igneous. Igneous means granite, diorite, things that we don't see in Israel except in Eilat and Sinai. Temper. We had this kind of temper. Obviously, these things, at least this group, does not come from Israel or Lebanon. So we decided to divide all this 130 something thin section into 4 groups. Definitely not Canaanite, the one that contains, for example, the igneous rocks, the granites, the gypsum, and also the combination of gypsum and igneous fragments points to the production in hyper-arid areas. It's like what I saw is a Wadi terrace, which was derived from a granite bedrock, and it has a reg soil which creates gypsum in the section. So definitely not Canaanite. Probably not Canaanite, because it contains temper and clay combinations not known from our collection. So maybe the temper in its own, like chert, could also, it's used very rarely, at least at the time, very rarely used in Canaanite pottery, although we have chert here, and so most likely not local. Doesn't agree with our database. And then most likely Canaanite contains temper and clay commonly found in local Canaanite pottery, but we could not say exactly where it is from because it was too general. And then a very small group, which we said definitely Canaanite. Temper not found in Egypt, such as basalt, or never used in Egyptian pottery, such as grog. Grog is a crushed pottery. So it was kind of way of putting things in order, and we look at different sources like Sinai. The thin section of pottery from Sinai look very different, but not match. And compared our data to previous neutron activation analysis, and like maybe 15 jars were analyzed by neutron activation analysis, and they used the database to try say where it comes from, and a lot of things did not agree. For example, neutron activation analysis says that this jar comes from the Hebron area, and we found bits of granite in it. And we all know that there's no granite near Hebron. So there was a lot of disagreements. And we also noted that the shape is not exactly, like I said, it's a little bit off from either sites in Israel. And the jars contained residual grapes, wine, and figs. And also the jars were sealed with Nile clay. The seals were made of Nile clay, which is very, very odd. So our hypothesis was that many of the jars were made in one location, and we should look around Abydos. Now, of course, the archaeologists didn't like it, but we just wrote it anyway, because for me it was the last paper. I couldn't give a damn, and Yuval put all his prestige on it. So here's a geological map of the area around Abydos, and all this brown stuff is limestone. There's nothing really interesting which could match what we see in the thin section. These are old Nile deposits like Lacustrine and alluvial fans. But if you look at the grand picture of Egypt, and I'm going to focus on this area, this is the Nile. You see there's huge range of rocks of every possible type. And here's the map. Here's the Abydos, Nile, and here's Wadi Qena. And all these wadis that drain into Qena will contain bits of granite, bits of gypsum, and you have a lot of the formations, like this formation, which is exactly like our takia, which is the clay carbonate with foraminifer with microfauna. So most of the materials that we find in the pottery can be procured from this area. which is, it's an outrageous proposal, because also they didn't find the workshops for pottery in Vatican or in Abydos. But this is what we wrote. We think that a lot of the pottery was locally made. And we don't have to be excited about foreigners or even local potters trying to make different pottery, because in my PhD, I found Egyptian looking pottery made of local stuff in the Western Negev. And of course, the archaeologists, when I told them it's local, they said, you're talking bullshit. But after a while, you know, they sort of realized that, yes, these are locally made Egyptian pottery. And the other way around, when I looked in pottery from Tel El Daba in the Nile Delta, there was some pottery which looked completely Canaanite. They were very white and the shape was Canaanite. And in thin section, they contained bones of animals to make them look white. So local potters were trying to be very inventive to get the pottery that they wanted, even if it's outside their usual tradition. Anyway, so this was the paper by Hartung a few years later, and they looked at three things sections from UJ, and another samples from other tools, not all from the same period, and they suggested they come from coastal Lebanon. I don't know. There's no granite in coastal Lebanon, and I don't know what the typology of the sites in Lebanon tells us. And as I told you, there's another paper which was recently published, which are not, I looked just at the abstract. They looked at a few more thin sections, and they say, oh, so it comes from Lebanon, and how it comes from, this assemblage comes from many different places, and shows the contact of the Egypt or the king of Egypt with different cities all over the Near East, maybe. Anyway, this is just to end it. This is the geological map of Lebanon. It's no granite. It's a little bit of basalt here, a little bit of shale, but it's very different. So that's the story. My work with the Yuval, and yeah, thank you.
Thank you, Naomi. Our next speaker will be Yarden Pagelson, who is a doctoral candidate and researcher at the Ben-Gurion University of the Negev, where he's a student of Professor Goren. His research focused in ancient metallurgy and Iron Age and Roman period, and his presentation today is entitled Iron Keys from the Roman Province of Judea Palestina, a typological and technological study.
Hi, can you see the presentation? Can we see it? Yes. Okay. Thank you. Thank you, everyone, for being here for this wonderful evening. Thank you, Amir. Thank you, Nama and Alex, for organizing it. This presentation is one of the test cases from my PhD research concerning legionary iron production in Roman Judea in the Middle Roman period. This specific research was done with other collaborators, Yoav Farchi, Dodi Mevorach, and of course Yuval. And I think it's a wonderful example of the type of research that I think can be associated with Yuval, because as we've seen from the other presenters today, the range of materials and periods. So now we have the Roman period, we have iron, so just another aspect, another different thing that Yuval has worked on throughout his illustrious career. The first time I met Yuval, he came to BGU at the tail end of my undergrad studies. And when I started my master's research with him, he said, oh, come with me we have a project in Crete, come and see what we do and learn and help. And that was actually Professor Panagiotopoulos's excavation at Koumassa, where we did an international field laboratory. And everything you see in this picture, this is at the Gortina Museum, where we examined different finds from the excavation and characterized them. And everything we carried on our back in backpacks on the plane. Through the years, It's been almost nearly a decade. I've worked with Yuval on the top right, you see our project at Engedi, part of the chalcolithic metallurgy research. Field lab was operating there because it was so hot, even in December with the sunshine, had to be put in a tent. You see in the middle, the work at Fatsael, and at the bottom right, again, covering all time periods, blasting a Barbie doll with a Raman Bethray right in the head. And we often say kind of microarchaeology, it's a niche, it's a very niche research field, but Yuval shows just how wide this niche is, all these time periods, all these different materials. And I think there's only one way that you can achieve all this, and that's to be curious. And if I had to define Yuval with one word, it's curious. As one of the more, let's say, experienced PhD students with Yuval, at least in recent at BGU, often other students come up to me and say, oh, I have samples that I need to sit with Yuval and look at. I have thin sections we need to examine. But like he's always busy. How do I get him to sit with me and look at them? And I say, just start talking about them. Start talking about what you see in the microscope. And Yuval's just so curious. He's gonna have to sit down, and he's gonna have his desire to see it will make him sit down and look at it. And that's how you get him. And it's my aspiration that hopefully I have as long a career as Yuval has, and we'll continue to have a long career, to remain as curious as Yuval has been throughout these years. So because we have an international crowd, just to put this all in perspective, this research is about Roman keys in the late 1st and early 2nd century Roman province of Judea. The borders of the province you can see in the image are marked by the line, and we have in brown we have the areas of Jewish settlement, which we will see will come to relevance a little later. We separated the keys to 3 time periods: early Roman, mid 1st century BCE to the last third of the 1st century CE, middle Roman, the last third of the 1st century CE to the first third of the 2nd century CE, and late Roman keys, to examine different types. Now, we decided to look at keys because, again, my research is about the legionary activity, but also in order to define that, we have to look at the opposite, the native or the local production. And in fact, there's very little research up to this day about both the production. We have some anecdotal reports of industrial wastes. For example, in the bottom left, you see from Fisher's excavation at Cholvat Mesad, he notes slag at the site, which is wonderful, but that's it. Actually, since I've begun the research, I began with only one metallographic study with Knox et al. 83 from Masada. Since then, I've published an article, and Stepanov et al. Published an article, so we tripled the number of metallographic studies, but until recently, there's been one metallographic study. And this created a feedback loop of no studies, so archaeologists are excavating Roman sites, and God knows there are many Roman sites in Israel, but no metallurgical iron finds because it's not in the literature. So again, we decided to look at keys as one of the avenues of this research. And we started, of course, for metallurgy, for metallographic studies. You need good conservation because you want to look at metal and not just at corrosion. And of course, where do you go if not for the Cave of the Letters, which has multiple keys in an amazing state of preservation. The Israel Museum was very gracious, and the Israeli Antiquities Authority, at allowing us to sample one key. You can see on the top left. We had 3 more keys in a very good state of preservation from a private collection from the Israel Museum with an unknown provenance. And then we also sampled 3 more keys from the excavations of Engedi. And that way it's still a small assemblage, but it's a bit more than one key, and we can say bigger things. Now, just a short history of keys. Obviously, keys can be made of iron, copper alloys, bronze, or wood. We're only looking at iron keys. Historically, keys and locks are already mentioned in the Old Testament. I'm not going to go into questions of anachronism when each text was written, but they appear there. And we also have locks in Mesopotamia from the first millennium BCE. The first keys we find archaeologically are from Greece from around the 6th or 5th century BCE, made from copper alloy. Now, my background is archaeological. Obviously, I studied the microarchaeology with Yuval, but I have to say, okay, we have keys. I automatically look at the typology because I see, as we can see from the plate earlier, these are very different. We have different shapes, different sizes. And the go-to place for key typology is Manning's publication of the iron keys from the British Museum. So we have, you can see the plate on the top left, we have lift keys. Oh, first of all, in terms of terminology, I use the British Fine Recording Guide. And we have, let's see if I can put pointer. We have the handle. From it, we have the stem that connects the handle to the bit, and we have the bit with the teeth on top of it. So we begin with lift keys, and they're pretty simple. This is from Persia from the 20th century, and there's a hole in the wall or in the door, and you use it to pull the bolt of that locks the door. We also have slide keys, quite a similar function, a bit smaller. This is a reconstruction of the lock from Pompeii. And then we also have lever lock keys, which you didn't see in our plate, that open more modern style locks, and padlock keys. What you don't see in this plate for Manning are elbow keys. And as a student of archaeology in Israel, I always, you see the cave of the letters, you see other finds from sites, elbow keys, yeah, of course, you know it, but I was surprised that I don't see elbow keys. Okay, interesting. So the aim of the study, first of all, in terms of typology, is can we take Manning's typological scheme and fit it to the Southern Levant? Because clearly it's different here. Why is it different? And in terms of metallurgy, what smithing techniques, what technology was used to manufacture those keys as typifying local native technology? And how does that compare to the analogous artifacts that were previously published? Through literature review and contacting archaeologists across Israel and the IAA archives, we've managed to collect 94 iron keys dated to the Roman period and create a database of the different types. I also add 16 Hellenistic keys in this chart just to show the differences. And again, the dates are given based on those in the original publications. I can't go into every publication and see if the context is perfect and so on. But what we can see is during the Hellenistic period, the majority of keys, in my opinion, are slide keys. We might have a couple of lift keys. In the early Roman, we have slide keys, and elbow keys appear for the first time. During the Middle Roman period, we have mostly elbow keys. We have a couple of slide keys, type 1, type 2 in Manning. In the late Roman period, we don't have elbow keys, maybe one, but lever lock keys appear and slide keys continue, but only the type 2, which is smaller than type 1. So we have, over the periods, using the typology, we can see the development and change in keys, and possibly we can also use them as facile directeurs to different periods. For example, if we have an excavation and we find elbow keys, I would not say that's a Hellenistic context or a late Roman context. To put it in a bit of a clearer perspective, in the early Roman period, we have the type 1 key, type 1 slide key, and elbow keys. The Middle Roman period, type 1 keys and slide type 1 keys and type 2. And again, elbow keys, they stop at the end of the Middle Roman period, the Bar Kokhba revolt. And in the late Roman period, slide keys continue, smaller ones, but lever lock keys appear for the first time. So I said, okay, we have elbow keys. I'm going to fit it in terms of the terminology, because Yadin also suggested names for the different parts of the key, but in Hebrew, and let's all fit this into a united terminology because we all need to speak with the same language. So the handle, from it extends the stem, fitting into the elbow metaphor, we have the shank that connects to the bit and the teeth. And I said, okay, again, we have elbow keys, great, wonderful. They don't appear in Manning, but let's look at other studies from and other collections and assemblages from other Roman sites of keys and find parallels, because that's archaeology, that's how we do research. And they appear in Petrie from his finds from Egypt, unclear exactly where, maybe the Fayum. But then looking at sites in Italy and England and Germany, you don't see elbow keys. You see the lift keys, you see the slide keys, you see the latch lifters, you see whatever this key is, which is similar, but it's not like an elbow key because it's missing an axis. No elbow keys. And it's very strange. Why are they only here and in Egypt, which is quite close? Now, looking at other figurative motifs, 2 elbow keys appear on a Darom style candle from Israel, from an unknown provenance. And these candles lamp, are securely dated to the Middle Roman period. And they typify the local Jewish population in Judea. And you can see 2 elbow keys, one with a wooden knob handle and one with a round suspension loop handle. Again, very connected to maybe to the Jewish population. Also, we have to remember in the Mishnah, there's a discussion about different keys, gamma keys, slide keys versus elbow keys, and the purity of each type. So there's an awareness with the sages of different types of keys and a different function, or a different, at least in terms of purity, a difference between the 2 types. I was mentioning the handles. If we look at the different types, we can see that slide keys always come with suspension loop handles. Elbow keys sometimes have suspension loop handles. The vast majority have pointed wooden handles. And there's 2 of them from the Cave of the Letters. The only 2 have button handles. Again, lever lock keys only have suspension loop handles. So therefore, we can also say, for example, these keys from Wadi Dalia, we don't have the actual key, we only have the handles. But since these are wooden knob handles, I would bet a lot of money that they belonged to elbow keys. And we can, even though we can't find the rest of the key, we can assign them as elbow keys. Now, looking at the technology of their manufacture, we did X-ray radiography to all the keys that we sampled. I would say that ideally we do this to every single metal object we find in the field. Wishful thinking. This allows us to do 2 things. One, we can see the state of preservation of the key before we sample it, or just in general, it's good to know. The green arrows mark areas of better conservation, red arrows, areas of less good conservation. And then we can have a better idea of where to sample the key and have a better sample from metallography. Furthermore, we can see in the key itself, you see the lines of the metal and the slag stringers. We can see how it was manufactured. We can see in the middle image, the long slag stringers is the metal was pulled, and the suspension loop handle was made. There are different ways to manufacture loop handles. This one was made by hot punching it and then expanding that hole. It's kind of like a Tour de France cyclist going around a roundabout. You can see the flow of the metal around the hole. A note about sampling, that just like excavating a site, sampling an artifact matters a lot to what you'll get in the end. We used a jeweler's saw equipped with a 250 micron silicon carbide electroplated steel wire with no liquid, lubricant, or coolant. That means that the amount of energy we were able to put in to cut the sample is very low, unlike sampling with an electric saw, which means that we're not causing any deformation to the metal. We're not introducing any heat to the metal, which might affect the microstructure. And also in terms of the sampling, both for the museum and for other artifacts, we're doing a very small, again, we're damaging the object, obviously, but we're minimizing that because it's such a small sample and we're not introducing all this electric shock into it. This is the metallographic results. We see that the keys were made from ferrite, very low carbon steel. On the top left, you see the key from the Cave of the Letters. You see in the middle and on the left, large grains of ferrite, and on the right, smaller grains. You can see in this image, contact zone between the small grains on the right, the bigger grains on the left, but we don't see a weld line there. And there is a transition. I think that's the effect of annealing the key after producing it, after forging it. But we do see some slag stringers in the sample towards the edge of it. And you can see in image D, ferrite, there's some perlite, not a lot. And on the right, this is one of the keys from the collection of the Israel Museum. On the left, you see the pure ferrite, very pure iron. But on the right, you have a acicular ferrite, this more acicular metal with slag stringer probably welded together, these two different types of metal. And on the right, there's an image of it, but it's also ferrite. So I suggest that I don't see really a technical reason to do it. And I think that it's probably the result of maybe recycling or fixing iron. And we can see that the keys are made from the ferritic and hypoeutectoid steels, but without any attempts in hardening them, which is similar but also different from other studies that show attempts at hardening. Maybe, I think it's a provocative thought, but that this is the result of some sort of recycling or secondary use of the iron. We don't see any evidence of iron smelting in the southern Levant during the Roman period. They had to get their iron from somewhere. On the bottom, we can see ingots from shipwrecks, on the left from the Western Mediterranean, but also in the Byzantine period, we have ingots that are arriving at the southern Levant. And I suggest that all the iron from this period in Roman Judea was the result of the transportation of iron, and there's no smelting occurring in the area. To conclude this, elbow keys are a unique type of iron key. They do have a unique spatial and temporal distribution around the province of Judea. They replace lift keys locally, and their distribution could be related to the Jewish population. And there are typological differences between keys which do correlate to chronology and space. And if we document them properly, we will be able to further refine these. And again, no evidence of smelting, and all the iron economy is likely contingent on maritime imports and recycling of iron. And again, the keys are not hardened. They're made from soft iron. Could it be for ductility? Again, you don't want your key to break. You can't go into your house then. Or is it just a result of recycling, which depletes the carbon in the steel? And to finish off, a key, Freund said this about a key from Bethsaida in his book. A key is just a simple piece of metal, except when it comes from a specific time and place, or context in archaeological terms, when it becomes salvation. So I hope we continue adding to technological studies for time periods, both from the Paleolithic all the way to the 20th century. And thank you so much. I'm sure there will be many toasts tonight and many more toasts and many more interesting studies in the future. Thank you.
Okay, our last speaker for today will be Idan Horn. Idan is a doctoral candidate and researcher at the Ben-Gurion University of the Negev, where he's a student of Professor Goren's. His research focuses on the disciplines of the archaeology and microarchaeology, and today he will be speaking about a provenance and technological study of clay liver models from Hattusha, the capital of the Hittite Empire.
Okay, everyone. I was asking everyone else to bring this lecture in English, so I will start. Provenance and technological study of clay liver models from the Hattusha, the capital of the Hittite Empire. Hattusha was the capital city of the Hittite Empire during the Last Bronze Age. It is identified as the archaeological site near the small Turkish town Bugazakoi, located 212 kilometers from Ankara. Since its discovery in the 19th century, the site has been excavated repeatedly by German archaeological expedition. Excavation has revealed a large number of cuneiform tablets, although most of them were written in Hittite. Many were written in Akkadian, the League of Franco of the time. The Hattusha corpus contained both intact and fragments of clay liver model. The location of the liver model found at the site is varied and includes temple number 1, Buyekle, Bildik E, and the Great Temple located in the lower city in the area. Clay liver models are part of systematic oracle inquiry called Akkadian Shuma Imeru, which include explicit practice where the cattle or sheep are slaughtered for identified physical sign and behavior. In addition, during the slaughter, an inspection of the inner organ, primarily the lungs and the liver, took place. Using animal liver and other inner organs for oracle inquiry is the ancient Babylonian practice, predating to the Hittite civilization. Many old Babylonian kings used CPC as part of their decision mechanism processes. The practice was performed by a diviner called in Akkadian Baru, meaning the seeker. In ancient Mesopotamia, the liver was the most examined organ because it was believed to be the center of emotions and feeling. Similar to how the heart is viewed in modern Western societies today. The Mesopotamians also considered the liver to be the tablets of the god, providing answer to the question posed by the oracle. After the slaughter, the diviner holds the cut liver in hand, inspecting the liver, let's call it in Latin, facies visceralis, which means in English the inferior surface, where the gallbladder is located on the lower side. Okay? The diviner examined the liver from right to left as it divided into several areas, each corresponding to a different metals. The inspector looked for various signs such as changes in color, shape, blisters, furrows, and different types of bulges. The clay liver model were part of canonization process and preliminary served as a teaching tool for diviners through documentation how to inspect the liver. These models were also created for teaching, documentation, and delivery. Instead of sending the actual organ after the ritual, the models were sent to allow others to examine them. It is now the time to present the optical mineralogy, the XRD, and the thermogrammatic analysis result of liver models found at Hattusha during the archaeological excavation. The aim of this research is to identify the specific area where these liver models were made, their production processes, and their technological features. Samples were taken from the liver models during the visit to the Pergamon Museum by Yuval Goren in 2012. The thin section were inspected under a polarizing microscope using magnification of 4D100x with PPL and XP light. I compared the topographic thin section to the Hattusha liver model to a thin section tablet made from Anatolia, south of Mesopotamia, and Yuval. Intentionally, I compared the Hattusha liver model to a Marna tablet, as you can see in the picture, sent by the Anatolian Hittite king and the Babylonian king to the king of Egypt. The Babylonian tablet was made with Euphrates alluvial clay, while the Hittite tablet was made from Anatolia, Izmir, Ankara, and Rosinkian layer clay. Additionally, I compared the topographic thin section of the Chatzor liver model. The liver model from Chatzor was made for common upper Galileite rich basalt clay. Results. As for the matrix, you can see incidence of quartz particles and mica. Both changes its color because of high burning of the clay. In the sample, there were several holes surrounded by calcite crystal. Overheating of the clay over 200 degrees causes these effects. The sample contained high amounts of feldspar mineral crystal and serpentine mineral were detected in the sample. The mineral hornblende was also detected in the sample and turned into oxyhornblende due to high burning temperature. In addition, several olivine minerals were detected in the sample. As for the inclusion, as you can see in the picture, were unsought and very coarse. The sample contained parts of crumbled or cold stone and feldspar mineral in the big size of 100 to 600 microns. As for the XRD result, we detect the following mineral: calcite, albite, quartz, moscovite, and orthoplast. As for the technological feature, the optical mineralogy and the TGA, as you can see in the picture, shows that the tablets was burned at 800 degrees. Interpretation of the analytical result. I argue that the raw materials used to make these liver models mostly come from a metamorphic or igneous rock formation. I can confidently state that the materials for the Hattusa clay liver models originate from the following. The first is the Izmir Ankara Rosinkian Ophiolitic belt located near the ancient city of Hattusa. Second, the Devisiag complex, which is also located near the ancient city of Hattusa, which comprises with various metamorphosed plastic rocks of the Triassic age. The Davishia complex also contained dominant rock types such as phyllite, metasedstone, conglomerate, metadiabene, and spiralite. Limestone and marble are also common in this area. The process of making this liver model is unique compared to other cuneiform tablets found in Hattusa. The mineral composition of the sample revealed that the potters used intentionally and coarse inclusion and burned the clay at a very high temperature above 200 degrees. These characteristics can also be found at the liver model discovered at Chatzor. Inspecting the model and compare them to other cuneiform tablets and liver models lead me to the conclusion that all three were made locally using raw materials from the surrounding area of the ancient city of Hattusa. Although they are rated in Akkadian, it seems that these liver models were created for local prophetic use and were not taken or sent to the Hittite Empire from southern regions like Assyria and Babylonia. One question that remains is why the creator of the liver model chose to use an unsought and very coarse inclusion and burn the clay at very high temperature, as I said, 200 degrees. While using coarse inclusion may help stabilize the clay during the burning process, it is not necessary, as there are many more advanced methods to burn or not to burn the clay to prevent cracking. Another subject is that the contrary to these liver models, in many clay tablets, there were no burning processes at all, and the tablet was only swept on every side by a thin layer of clay to create cladding using a damp cloth. I may argue that the use of coarse inclusion and burning of the clay in this case is not for technological reason, but for religion purposes. I have several references in academic literature regarding prophecy that require the use of soil from the specific area related to oracle inquiry. There are numerous letters from the ancient city of Mari, for example, that discuss using cloth of earth or other object from the city in question. For example, as you can see here in letter IRM 26-184, the servant Itur Ashdu reports fulfilling his law request by bringing the cloth of earth from the city of Urgish, Ashtaraka, and Shuzuzum for specific purposes. I argue that although the clay liver made in Hattusa, its creator had unsought and very coarse inclusion as part of the costume and old tradition to incorporate the earth from the area. However, it is not always the case. We have several instances where the diviner is asked to bake and send the inner organ, especially the liver.
for further inspection in the king courts or by a higher diviner. The baked-in, of course, to prevent anyone from alerting the model during the transportation, physically and spirituality. Such requests are found in the Mari letters, number 26, 108, 126, and 28, as you can see. Sending a decaying organ in the hot desert in the ancient Middle East is not a simple task. Therefore, Leo Oppenheim suggests that instead a clay liver model was made, baked, and then sent for interpretation in the king's court. The similarity in both liver models from Hatzor and Hattusa, which use unsalt and very coarse inclusion and are fired at very high temperatures, lead me to conclude that diviner holds the soil from the area he inspected into the clay and then burn it as a part of the costume, resulting from the transition of knowledge from how to create the clay liver models. In the late Bronze Age, tradition for creating liver models were passed from Hattusha from southern civilization like Mitanni and later Assyria and Babylonia. The first snow clay liver model in Hattusa, as we recognize it today, dates back to the Middle Kingdom period when Hattusa had direct contact with Mitanni, Babylonia, and Assyria. I can assume that during this time, Hattusa diviner were learning about Shumai Meru along with various tradition for creating clay liver model. The Mari archive reflects just one of many aspects of old southern tradition that was common at the time and likely spread to Hattusa and Hatzor, along with other southern tradition, through later kingdom like Mitanni during the time. To fully address the question of when and where the practice of adding soil and burning the clay liver model began, future microarchaeological research on Assyria, Babylonian and Mari liver models will be necessary. תודה רבה.